Yeah. Will it only share the master one?
Where?
Yeah.
I was trying to connect the last time.
Hey Lou, can you hear me?
Yeah, we can.
Hey Lou, can you hear me?
Yeah.
Way you can zoom in closer. That way, because I know Representative Lundstrom's probably going to want to see what's on that screen. Can you hear me?
Yeah.
Way you can zoom in closer. That way, because I know Representative
Okay, there we go.
wants to see what's on that screen. Can you hear me?
Yeah.
Way you can zoom in closer. That way, because I know Representative.
Okay, there we go.
I think that's good.
No, they're linked, so they should be playing the same thing right now.
Closer.
Like, we're unmuted and Carol's unmuted. That's what happened last time.
Yeah.
So it's gonna seem like.
We'll be fine. She'll be muted. Is
Yeah.
that better?
That works.
Yeah. Okay. Well, let's see.
As far as Mr. Tallhammer,
Do you need this up right now? What's that? Presentation?
Yes.
Okay.
Oh, no, presentation. What's that? You missed the presentation. I wasn't sure. Oh, you're on? Yeah.
Can you take that off? No, yeah.
Yeah, if you just put that little box in the bottom right corner, it'll be fine. It'll be fine. About a minute here.
So are you able to share?
Yeah, yeah, okay. Okay.
No.
That's it, sure.
I got you. Okay.
Was there a reason I needed to stop sharing?
I guess to initiate the meeting, they wanted to have a lockdown first until.
Okay, so I can still, I still have to.
So you should start the bill these days. You should start the bill these days. I don't understand why we're giving the legal.
We're gonna leave that mic. We're gonna leave that mic.
It should pick up here, but. We're gonna call IT real quick.
Yeah. Yeah.
Move it out.
Yeah.
Is everybody muted? All muted? Y'all muted? Y'all muted? Okay. Does Carol say it's okay for her now?
Says high school, you did.
Yeah, quick test, Carol, can you, tell if you're okay from your end? Okay, I think we're good now. That was good to go. Okay, thanks. We're good to go.
Thank you, Mr. Deal. All right, we are on the record. Mr. Nolan, go ahead and call your next witness, please.
Petitioner calls Steve Park.
Come on up, Mr. Hart. You swear upon the testimony about the hearing and hearing is going to be the truth, the whole truth, and nothing but the truth.
I do.
Thank you, sir. Please proceed, Mr. Nolan.
Hart, please state your name and address for the record.
My name is Stephen with B, Hart, H-A-R-T. Business address is 2923 South Tryon, Street, Suite 100 in Charlotte, North Carolina.
Where do you currently work?
Company called Hart and Hickman.
And what is Hart and Hickman's purpose or mission?
We are an environmental consulting and engineering firm, focused mostly on soil and groundwater contamination issues.
What is your title? I'm sorry, what is your title with that firm?
I'm a principal hydrogeologist at Hart.
And what responsibilities does that entail?
I have a technical responsibility for a number of projects that deal with soil and groundwater contamination.
And what's your tenure at Hart and Hickman then?
We started in 1995, so a little over 33 years.
And what was your work before then?
So before that, I worked for a company called Ames Moore, which is now part of AECOM, which is an international firm doing the same kind of thing. I was a hydrogeologist, worked with them, and I was the manager of the Carolina region.
And what years did you do that?
93 to 95, 1993 to 1995. And before that, I worked for Environmental Resources Management, which is also a worldwide environmental consulting engineering firm. They also worked there from 1989 to 1993.
And was that your first job out of school?
Yes, it was.
And what is your educational background?
I have a bachelor's degree in environmental science from the University of Virginia, specializing in the areas of hydrology, which is the study of surface and subsurface water, and also in geology, which is the study of earth processes. I have a master's degree in geology from Texas A&M University, where I specialize in hydrogeology, which is the study of subsurface water, and also engineering geology, which is the study of effects of geology on engineering structures. My thesis was done on developing a technique to monitor groundwater quality of municipal soils.
Are you a registered engineer, professional engineer?
I am not.
Oh, excuse me, a professional geologist?
Yes, I'm a professional geologist in the state of Arkansas, Alabama, Georgia, Florida, Tennessee, North Carolina, South Carolina, Texas, Washington, Wisconsin.
How's this document?
I do.
And what is it?
It's a copy of my CV.
Does it summarize some of those educational and practical experiences that we've been discussing?
It discusses, it includes my educational background, as well as some of my key projects and experience.
Ask this be admitted as petitioners.
It's four.
Four.
Any objection? Objection petitioners for is admitted.
Have you served as an expert witness in groundwater cases before?
Yes, I've served in, as an expert witness, in many, groundwater contamination cases in both state and federal waters in North Carolina, South Carolina, and Arkansas. Areas which I've been, designated as an expert with hydrogeology, groundwater contamination, big transport of contaminants, assessment remediation, groundwater monitoring, groundwater remediation, groundwater cost of remediation, compliance with environmental regulations, including the national contingency.
Did any of those cases involve karst?
Yes, they did. I did testify in state court up in Boone County on a case involving karst with regard to joint contamination from a bulk storage facility where there was impacts to water supply levels. Pre-product, yes.
I remember that case.
Your Honor, may.
You said Boone County, and Judge Bolton reminded us that Boone County, Arkansas. Is that correct?
Yes.
All right. Can you define karst for me?
Yeah, karst is a typically associated with landforms, but those landforms are created from the dissolution of underlying soluble rocks like limestone, dolomite, gypsum. So because of that dissolution of those rocks, it creates certain landforms that are associated with karst terrain, which can include sinkholes, caves, springs, sinking streams, and a number of items that are associated with karst.
Is karst present below the Eco-Vista site?
It is an area with karst shelf.
Again, Your Honor, we're going to elicit expert opinion testimony today. I don't believe we're making an individual ruling as we would in circuit court.
Not a problem. He's an expert.
Thank you. Can you tell me a little bit about your preparation and review of materials pertaining to the Eco-Vista site?
Yes, I viewed a number of documents that are in the public record, that are on the ADQ website. Went through pretty much the entire file, not every document, but looking for things that would be pertinent to my expertise, geology, geotechnical information, the hydrogeologic, etc. models, the class 1 permit application was recently class 1 permits, groundwater monitoring information, dye tracing studies that have been done. To try to go through that with an eye on things that were relevant to my expertise and my understanding of geology and hydrology.
You review any guidance documents or items not found on the ADQ website?
Yeah, I've used some of these guidance documents before, obviously, but there is, karst monitoring, groundwater monitoring guidance that EPA has put out. There's a number of studies in the area with regard to dye tracing tests, hydrogeology, regional hydrogeology. In the area, I also reviewed some dye tracing studies that were done by Dr. Brahana out of the University of Arkansas, and reviewed those in relation to evaluating the regional, not just specific to the Eco-Vista area, but also what is found in karst terrains, where the boom formation is present. Got here, this landfill, see what kind of information I could glean from those regions, geologic study. Well,
Do you recognize we have a slide on the board up here with some points from that groundwater monitoring guidance Can you tell me a little bit about what characterized by conduit flow and diffuse flow means and what would be expected in karst topography?
Well, in course, you can get diffuse flow and conduit flow. Diffuse flow is kind of what we think more as a typical hydrogeologic groundwater condition. That's where you have water that's in the pore spaces, both in the fractures of the rock, but also in the overlying, they call regolith, which is clay material, and also the epikarst, which is highly weathered rock. You get kind of what we consider typical ground flow, moves fairly slowly, relatively slow, and predictably. But in karst regions, you also get what's called conduit flow, and that occurs when you have underground cave streams, which, because of the conduit flow and recharge associated with them, you get significant transport, very high velocity transport in some cases, and in locations and areas that you wouldn't expect if you consider, underground diffuse flow system. So as indicated there, you have very high extreme velocities in some conduit flows for 30 to 50 feet per hour. Typical Eco-Vista, I think the most recent dye study, even though there wasn't anybody monitoring for the dye, showed at least a groundwater flow velocity of 100 feet per day. So very high groundwater flow velocities in the conduit flow, which is part of moving emissions in this type of.
Second slide from that same guidance. What does that guidance tell us about monitoring in karst topographies?
Well, it's in karst topography or karst geology, where you have a conduit flow, you have very different monitoring requirements as you would for a typical site. You need to be monitoring springs and cave streams, and also you can use monitoring wells, but they need to be shown that they are actually connected using dietary studies to the area that you are investigating. You can use wells, but as I said, they need to be shown to be connected to the area because you have these conduit features. It's difficult for a, for example, a 2-inch diameter monitoring well to intersect a unknown location of the cave stream. So where you need to monitor is at springs, cave streams, seeps, and other areas. And sometimes these areas are several miles away. That's what is shown in karst geology. That there are conduit flows that they flow in many cases in multiple directions, and they're not necessarily associated with specific what we would consider topographic or groundwater basin under normal conditions. Sometimes those cave streams cross those what we consider groundwater boundaries.
So that first point on the board, which is a quote from the guidance on where to monitor, it states that springs, cave streams, and wells shown by tracing to include drainage from a facility to be monitored rather than at wells which traces have not been run, but which were selected because of convenient down gradient location. Do you agree with that statement?
Yes. In fact, there's 2002 EPA guidance that says groundwater monitoring at monitored wells that have not been shown connected by tracking dye trace, which is irrelevant by the false sense of security that there hasn't been released because they're not connected to the geology and the primary zones of transport geology.
We have an illustration here.
Yeah, that's just an illustration of kind of karst landforms. Some of the common ones are things like sinkholes. Again, a cave spring is a cave that has water coming out of it. There are underground features like the cave or the conduits that we talked about there below ground. sinking streams or streams that, you know, are kind of flowing on the surface of the ground and then disappear into a sinkhole, or some other conduit below. And so those are the types of features we see in karst geology.
This illustrate or be read in conjunction with the guidance that says you can't just monitor at convenient down gradient locations. Why is that important in karst?
Well, that's because of these, you know, conduits that are present that discharge, if you don't hit that conduit with a monitor, but it's got the highest groundwater flow velocity. And it discharges to springs. The location where you would monitor that is from a spring, not from a monitor well, which hasn't been shown to be connected to the hydrogeology site. So that's why we, you know, premise is that you would monitor at these springs, which are, again, if you're trying to detect contamination as soon as possible, as required under Rule 22, you would be monitoring at these springs. Because that's where you're going to see very high groundwater flow.
Why do we have to pay particular attention in karst topography when it comes to waste disposal facilities?
Well, in karst, you can get contamination that, you know, travels a long distance, miles away. And so, you know, you want to be able to detect that contamination as there has been a release so that it can be monitored and remediated in terms of impact the human health environment. So it's indicated in this from EPA's groundwater monitoring karst terrain. Waste disposal facility should not be located within karst terrain unless one is going to risk sacrificing the use of at least part of the subadjacent karst aquifer as a source of potable water. If you do have a release, it's going to be hard to remediate it. It's going to go long distances, and if you're not monitoring in the correct location at these springs long distance away, you can have impacts to human health environment which aren't being detected.
Do you agree that the next sentence there, that it's a high risk, almost certainty in karst terrain?
Yes, I mean, it is. It's, well, we've seen it in Eco-Vista, they do have groundwater contamination. But it is a high risk, very high risk, because of the type of geology that's present because of the extreme groundwater flow velocity.
We have another statement here on monitoring. Let's talk a little bit about how to design your monitoring network in a karst terrain. What does this guidance tell us about the location and where to monitor?
Well, the most reliable and proper monitoring in karst terrains are at springs and other discharge points, typically outside the boundary of the facility, not necessarily keep guide springs or some other things. On your facility property, you could have springs or seams, which could be locations, but usually those are outside the facility boundary because typically they're not in the way. You can use monitoring wells, as I've said, but they need to be shown to be connected to the groundwater geology underneath. And so putting in random wells is not acceptable to monitor the groundwater.
Another issue we'll talk some more about later is frequency or timing of monitoring events. What can you tell us about a properly constructed monitoring program when it comes to frequency or timing?
Well, typically, the greatest groundwater flow velocities, the greatest potential you could have contamination migrating from the area is during when you have storm or meltwater events. That's because you got send your recharge that occurs very quickly, so you can get flash conduit flow. And so that's the time that you should really be monitoring in karst terrains, in these springs, also in monitor wells that are shown by the titration the area of concern. Because in his conduit flow, that's where the significant recharge and flow through is going to Now, it's also a good idea to monitor Facebook conditions too, to see what that looks like. So you compare it to events, meltwater events. But doing it kind of routinely, quarterly, semi-annually, monthly, that kind of thing, and or whatever, without evaluating recharge conditions for storms is not ideal. You know, the EPA guidance that we've been mentioning says, you know, just sampling on the same day, quarterly or semi-annually, is like collecting rainfall data 2 times a year and then extrapolating that for the entire year. You've got to really look at those stormwater events to see where the flow events occur that may be, that may be transporting the primary mass from, if there is contamination from landfill or whatever other potential source of contamination.
Josh, right, this moment ago. You recognize this document?
I do.
And is this the guidance that we've been discussing over the last few minutes?
Yes, it is. EPA's groundwater monitoring department range guidance from 1989 put together by Quinlan. It's cited off in the titrations for types of parts investigation protocol.
Your Honor, ask that guidance be admitted as petitioners.
Objection.
Objection.
Thank you. Without objection, petitioners 5 is admitted.
Did you review any other studies that are relevant to Karst in Arkansas prior to your deposition and giving an opinion in this case?
I did review, there was actually in this 1989 guidance, they actually have, example of a titration study for proposed landfill. And then, which is shown here. You can see kind of the, and this is in those arcs here. The blue is where they injected dye. Not easy to see, but the number of arrows you can see are areas where they traced dye to different springs. So long distance away, several miles to 3 or 4 miles away from where they injected dye, they were seeing groundwater contamination, or excuse me, they were seeing dye, evidence of dye showing conduits between these injection locations and where they were detecting each spring. So they didn't monitor right around the area where they injected. They monitored in some cases several miles away to determine where the discharge points are in this program.
Did you review another more recent study?
Yeah, I reviewed work that Dr. Brahana did with regard to a animal feed operation. I think it's a hog farm or some sort, but maybe something on or a chicken farm. Anyway, they were looking at, this is near the Buffalo National River, and we're trying to look at where groundwater from this feed operation, where they were also doing plant implementation, was discharged. And see the CAFO is where they were in the area they were monitoring, and they injected in that yellow star, which is kind of the southern part of the blue outline, which is CAFO. And then they monitored springs and streams in the area to see where the dye showed up. As you can see in those areas where there was positive dye tracing. Many locations, many across the topographic divide, all throughout the streams and springs, some in that scale up there is 5 kilometers 3 miles or so, a long distance away from where the dye was injected. They were getting sections of dye. And then from that, they did recommend some sampling sites for routine monitoring, which are shown there in the yellow box. So that's how the study of what you'd expect to dye tracing study, where you see many connections to springs and stream long distance away.
So kind of generally, what are the lessons learned from reviewing things like Pendle or here at Mount Judy near the river? What are those things that you can learn about karst topography and dye tracing?
Well, the dye shows up in places you don't expect it. It shows up, can show up a long distance away. It can show up, short distance away. It can't show up long distance away, but the places to monitor primarily are in springs and streams that are distal from the area under investigation. And your typical groundwater pond, where you just randomly install wells.
Just a second. Got a phone ringing up there.
On three. All right, it's shut off. Whoever was trying to call has hung up. Please proceed, Mr. Nolan. Sorry about that.
All right, I think we mentioned it a moment ago, but we've just talked about some background materials. Tell us one more time how you got into the actual record of this case and what you focused your review on there to familiarize yourself with the Eco-Vista site specifically.
Yeah, but again, like I said, I put into the record, looked extensively through the record on the historical geologic reports, hydrogeologic reports, dye tracing tests, try to come up and summarize as per the rules, kind of going through that all the prior investigation to figure out, going all the way back to the first dye test in 1996, looking at the cross section, looking at boring logs, looking at that kind of information, come up with what I consider to be an appropriate hydrogeologic model for this site based upon all those studies, and also whether the groundwater monitoring system that's in place is adequate to detect contamination as soon as possible.
Well, let's talk a little bit about Chapter 11 of Rule 22 first. Did you review Chapter 11, a copy of which I put in front of you there?
Yes, I did. Or you, yes, Rule 22, Chapter 11. Yes, I reviewed it.
All right, can you look at 1102(1) and tell me what is required by 1102(b)(1)?
So 1102(b)(1) requires that a conceptual hydrogeologic model of the site be developed, and then all characterization studies must be integrated into a comprehensive geologic model which accurately describes and explains the site hydrogeology. The model must be of sufficient detail to base the design and be used as a predictive tool for potential contaminant migration and serve as a basis for corrective action.
Can you tell me, in your words, what that means to you, especially the comprehensive geologic model language?
That means, yeah, going back, looking at all the historical data, all the historical dye tracing tests to show what they indicated, looking at the geology, looking at the groundwater elevation maps, looking at what has been tested, hasn't been tested, with regard to areas, and to come up with a hydrogeologic model based on all that data that's been collected to date so far at the Eco-Vista.
All right, and let's look a little bit at 21.1102C, moving to the second page there under 2. What do 3 and 4 on the first page direct be included when conducting a site characterization?
Identifying within a half-mile springs and seeps, and domestic, agricultural, and municipal water.
And under number 5 on the next page, what does it require that a site characterization include?
Looking at the water table or potentiometric surface map, that is, we look at groundwater elevations, multiple wells, make predictions about which way groundwater flows, which is the second or third groundwater flow directions, the hydraulic connectivity values. Hydraulic connectivity is a measure of the aquifers or aquifer's ability to transmit water. Looking at vertical and horizontal gradients. Horizontal gradients are kind of the gradient of potentiometric surface for the groundwater surface, so we can determine which way groundwater is flowing. But there's also, it's not just groundwater just flow for horizontal, but it's also vertical. And so both of those are very important to determine how contamination of groundwater or groundwater is moving in potential contaminants. Use of pump tests to look at hydraulic communication between units. Also information about groundwater flow velocity and ambient groundwater temperature.
All right, and what does D there tell us, again, where all this information is supposed to be compiled?
Yep, all these studies are supposed to be integrated into a comprehensive hydrogeologic model, which is a written report certified by qualified groundwater scientists. The groundwater recommended groundwater monitoring points, not necessarily well, must be included in the locations based upon the site hydrogeologic model. And all maps and cross sections included in the written report must be and show, items of typically be a cross section, like one location. Your take your feet.
Moment, yeah, I thought I was plugging in.
All right, let's review one more here in chapter 11, and that's E. Boone, St. Joe, Aquifer, Northern Arkansas. What additional measures are required by chapter 11 when you are in the Boone or St. Joe Aquifer?
Additional measures would be a detailed surface mapping of all karst features, including but not limited to sinkholes, springs, losing stream segments, caves, buildings. Subsurface exploration program system of core drilling at minimum spacing of 24 per acre, downhole video log, geophysical log of each boring, and also a groundwater diatrace study to test the accuracy of the site's conceptual hydrogeologic model. The dye study methodology must be improved by vision and shall consist of a sufficient number of monitoring locations, which will include wells, barometers, streams, and springs.
All right, so with this in mind, let's go where you largely began your review of the site. Tell us a little bit about what the purpose or objective of the 1996 dye test was.
Well, yeah, so they've done a series of dye tests starting in 1996 all the way up to the 2022 study that was done over time. I kind of went through each of those because those are really the key to understanding which way, how groundwater flows. And in some cases, they can follow differently than we think with regard to the potentiometric surface map because of these conflicts. these subsurface comments, and also to look at what springs and seeps have been looked at, have been sampled during dye test, but also to get an idea of which way those show groundwater flow. But if you want to go back, there were in the previous slide. So they did inject, and typically with these, there's not just one injection, they typically inject 2 or 3 locations, use different dyes at each location to see kind of the points where the different dyes would show up. I included in green kind of the general location the dye testing was done. And then if it has a green box around it, that means it's a monitoring well that showed connection to that dye trace or to that dye injection point. And if it has just an empty box around it, did not detect dye. And so, I mean, really on these dye tests, what they're looking for is there a connection to monitoring wells that could be used for monitoring the landfill? And then also, is there a connection to surface water springs? Surface water springs on the site. And so, and you can see that there were some, and the other thing I'll point you out to is that it may not be obvious, we can discuss it later, but I did also mark in highlighted in yellow those monitored wells that are part of the facility's current groundwater monitoring system, to see if there are any wells, monitoring wells, that have shown dye trace studies to connect to the hydrogeology. That would then show that those are appropriate for monitoring groundwater specific wells. And I think, you can see here that there were traces to 3 or 4 wells fairly close by to where the injection points were, showing radial flow from the injection points mostly to the northwest, which is opposite to the direction of groundwater flow that is indicated by the tension metric map, which is to the southeast.
Let's illustrate that. I have a little better picture here. It's a little fuzzy up there. Can you show us by pointing on this map where you were talking about a moment ago that as early as 1996, there was an indication of flow in what direction?
So they injected here and they know that there was flow in a northwest direction. The tensiometric maps, which might give you an indication of groundwater flow on the groundwater elevations in specific monitoring wells, have shown a groundwater flow to the southeast. And so what this is telling us, in which they actually changed their conceptual site model in 1996 to indicate that there was groundwater flow to the northeast and that groundwater flow was radial. Contrary to the previous conceptual site model, which indicated that groundwater flow was to the southeast. Now, it's not unusual to change one's conceptual site model. As you get more information, conceptual site model, conceptual hydrogeologic model change. But what it showed specifically, this dye test, is there was a component of groundwater flow to the northwest, as opposed to what everyone thought. And some people still think, I will find you as late as 2022, that groundwater flow is to, that they indicated southeast. But here we have evidence from the dye tracing studies that groundwater flow is in this region also, or in this area is also to the northwest. And I believe they indicated, I think we can slide about that, that there was radial flow indicated by the dye tracing studies. With regard to the spring data, they monitored springs that are shown there. They have a box around them. There was a definite connection, in my opinion, to Glass, which is located south along Clear Creek, I believe, is the one that's directly south of where I have the arrow.
Yeah, it's a little fuzzy up there, so feel a little straight for Judge Moulton.
Yeah, so it showed a connection to Glass Spring. Dye showed up about 2 months after injection in Glass Spring. It all showed up in Upper Clear Creek, what they call Great House Spring, which is about 4 miles away. This line here is about a 4-mile distance from the center of the landfill. And also showed up in what's been called SB6 or Spring Department on Wildcat Creek. They discounted those results because they said that, dye was showing up in SP6 and Great House Spring. And those what they considered their upgrading points. And therefore discounted the results not only in Glass Spring, which showed a strong connection, but also in these two other locations. Well, we have seen in the dye studies, there is no upgrading. This is on top of a hill. Everything is downgraded. And so you have 3 springs that showed connection to this landfill. They were all discounted because they indicated that, they felt that the 2 Great House Spring and SP6 were their upgrading points, despite the fact that, we're looking at these other dye tracing studies, is the dye can go a long distance in any.
Let's talk about a few of the specific documents associated with these 1996 studies. And I've got document ID 5105, which is a response to comments from Genesis to the Arkansas Department of Pollution Control and Ecology. And we're at page 7, which is in the actual comments there. What was their understanding of groundwater velocities at the conclusion of these tests in 1996?
Well, they were of the opinion that the groundwater velocities were slow. Now, this is, I think, discounting what they discounted the spring data. They included the spring data. They would have seen groundwater velocity higher. But you can see that they did also say that they revised their conceptual model to show that there's an upgrading for northwest flood.
And so let's discuss that. We're still in document ID 5105, and we're at pages 37 and 42. And now we're discussing flow direction. What was their understanding of flow direction in 1996, and what is your evaluation of these statements?
Well, as I mentioned, I think that, just looking at what you typically do on a non-conduit groundwater flow car site is that the groundwater flow direction was to the southeast. But as you can see here, at that time, even solid waste division expressed concern that the flow direction cannot be expected to work in a single direction due to cars groundwater flow directions. And I would certainly agree with that.
What are we coming back to here at page 42? Which regional groundwater flow is to the southwest, but as stated above, flow across the site appears to be the southeast.
Yeah. So there's there's a number of these instances where they continue to go back to the groundwater flow being in the southeast and ignoring the results of the dye tracing, which in this case, 1996 showed flow to the northwest. In what they consider upgrading downgrading from the site. So, but again, kind of the people working on the geology of the site are times that kind of work a lot of the diagrams.
Well, we're still in document 5105, but now we're at page 52. Tell me a little bit about what the overall conclusions are of the 1996 dot test.
Well, so they say that flow occurs in the bedrock has diffuse flow in the joints and fixtures, which it does, but it also early on recognized that there were solutionally enlarged fractures. In other words, there were cave streams where moderate flow occurred. And then they go into the tensiometric surface map had consistently showed groundwater flow to the southeast, but the dye test indicated that there was an upgraded flow direction. And they had monitored their groundwater system, or it says their monitoring system, to count for radial flow, which I would agree there is radial flow. And then they go on to say that the first, the uppermost aquifer is the first avenue of escape from the landfill, which is the bedrock aquifer. And then that material, the residual material, or the clay material overlying the karst aquifer is clay, fairly low permeability. It partially defines it off.
I think we hit it a moment ago, but key point on here and identify the springs, and not bring that other image back up, but where in 1990, as early as 1996, that there was indication of flow in a direction other than the south.
It was showing flow up towards the northeast. So this is a map of all the springs in the area are included here from the United States Geological Service topographic map. So those are locations where they specifically labeled spring or springs. They're in blue, and then some of these additional springs were identified SP 1 through 5 plus a clear spring were also identified and included in before the diagnosis. So you can see that there's, on the order of 20 to 80, 18 to 20 springs on the USGS map, and then a number of additional springs that they located for the digest. But only these closest to the land. Now they've never seen, but as we see right here, and this, none of these other ones you see on here are government tested.
Mr. Nolan, can you hold on a second? Well, I'm just gonna, if I could bring that back to Mr. Hart. Could you orient me towards, so all the documentation, Mr. Hart, that I've seen says that when they did the dye test in the class 4 area that it manifested in Wildcat Creek. But I don't see anything on this map that demonstrates where that is.
Okay, this is Wildcat Creek.
Okay,
So where that 2022 manifested was in FP6.
okay. All right, so Wildcat Creek is different than Clear Wildcat Spring, two different locations.
Right. This
That's
is
what I wanted.
Clear Creek. This is Little Wildcat. This is
Okay.
Wildcat.
Okay,
They found that 22 at SB6, which in 1996 they also found, but wrote off.
all
They
right,
also identified in Flat Spring. They call Great House.
all right, thank you for the clarification. Sorry, Mr. Nolan.
Right. So we have a small period of time, couple of years in here between the 96 test and the 97 results before we get back to testing in 2001. Can you tell us a little bit about what your review of the record indicates was happening during that time period?
Yeah, so they did identify some groundwater impacts in their landfill perimeter wells in the late 1990s, early 2000. So 2 out-of-use water supply wells located northwest of the landfill had chlorinated solvent contamination, things like trichloroethylene, 1,2-dichloroethane, were detected in those out-of-use water supply wells. Based upon that, they did some sampling and identified contamination consistent with the landfill, the chlorinated solvents in Glass Spring. So that would be consistent with the dye test from 1996 showing contamination in Glass Spring, or at least a flow from landfill to Glass Spring. There was a memo that AEQ personnel had met with Dr. Brahan, indicated does a lot of harsh work in dietary area, and that the results showing groundwater contamination flowing to the northwest was quote unquote puzzling. have always considered groundwater flow to be to the south. And they thought that was potentially the result of the utility underlying shale. At that time, Dr. Brahmana, in consultation with ADQ folks, recommended investigating springs north and south of landfill, including the springs and farming community, which is SB6, just talked about, and also beyond SB6, because the contaminants may extend through a common flow further. I don't see any indication that those recommendations were ever implemented. I don't see any indication that any springs out beyond Harmon Spring investigated, or that other springs in this time frame, well, any showed either north of the land, south of the landfill, or same. There was also a cave-in identified in fall 2001, just north of the last world landfill area. That was discussed in an affidavit.
So our next round of testing and investigation occurred in 2001 to 2003. Can you tell me a little bit about the work that was performed then, and what was the impetus or the why were they spurred to action again in this time frame?
Well, I believe, well, I'm not sure why they referred to that, but they did a dye test in 2001 and 2002, and then they did a follow-up testing in 2003. And you can see again the locations where they injected dyes, green arrows, and they would use different dye in each location, and then monitor where they found it. And the boxes with green is where they detected dye, and the boxes, the boxes with without any green are locations that they monitored. You can see there are some primarily located southeast of the landfill, which is the direction we also would expect. And there's also geological fracture trends, structural trends that run northwest southeast. So not unexpected. There is, you can see as well, southeast corner, that is one of the monitored wells that is monitored regularly. So it did show a connection to one of those monitored wells. But you can see there's a number of monitored wells that are highlighted, that are used for groundwater monitoring, where they do not show any connection to the landfill. I think this may have been this data result of the contamination, which they thought the dye injection on the far southeast corner was very old. So it's that dye testing, they also monitor springs. They monitored the same springs they did in the 1996 one. In this case, they did positive dye detection in Harmon Spring, SP6, 7,000 feet in 50 days.
What would you characterize groundwater movement of 7,000 feet 50 days as?
Very fast. It's hundreds of feet per day, which is extraordinary. What they said after this dye testing result was, well, that can't be. The only possible way is through an open conduit flow. And we drill all over the site. We don't see anything like that. So we're going to discount those results. The fact that SP6 showed consistent with what you'd expect from karst geology. They said, no, we're going to discount those results because they just can't be. Like, we haven't seen evidence, any evidence that there's solution derived conduit flow.
Let's look at that. We are looking at the 2003 dye test, and the citation is on the second slide here. There's two slides for these conclusions, but we're at doc 23178, page 20 of the revised dye test study report of May 5th, 2004. And so you began to allude to it there, but here we have Statement that spring SP6 is located approximately 7,000 feet from DOM 1 and had detections in August 31st, 2001. Tell me what is going on with the agency and with the determinations that are made next regarding that finding.
I'm not sure I understand.
Oh, I'm referring to paragraph 1 there.
Well, the conclusions from that dye study, as I mentioned, was this can't happen, right? Instead of having the dye trace study define the hydrogeologic model, we're going to take the hydrogeologic model and anything that doesn't agree with that, we're going to ignore. That's not how science works. That's not how you develop a hydrogeologic model. You're going to ignore the data and then say, well, we're not going to change our geologic model. This can't be. That should have changed completely the hydrogeologic model that had been determined for to say there has to be constant flow inside of springs, not discounting the results because they didn't see it in some form.
Was there any action taken on this result to adjust that model?
Not that I'm aware. They kept monitoring it, monitor flow locations. They did monitor the springs. They indicated, as you see here, that they thought it might have been an auto body shop that used any without any evidence whatsoever that this dye shows up the same fluorescent wavelength as the dye that was rejected. We're going to blame on some auto body shop. I went out there. And the other thing I could read on the test, I'm concerned about. This is a big deal. We got to have a solution. Conduit flow, hundreds of feet per day, or groundwater flow. We can blow it off if you make money from somebody's getting.
And again, we're at doc 23178, page 20, paragraph 3. So is this an instance where the model is determining the facts, not the facts determining the model?
Yes, ignoring the facts because they don't work with your supposed hydrogeological.
All right, did they continue to look at the karst features of this area during this period of study time? We're at doc 23178, still at page 26. What are they discussing here?
Yes, they're looking at, they have to identify karst features as part of Rule 22. And instead of going out and doing an investigation of karst features like springs, sinkholes, that kind of thing, they just say, well, this is immature karst. Looked at the Geosyntec 2022 report, and we don't see any of these things. It's not really developed in this part of it, which is not true.
Now we're still in doc 23178 at page 26. But they also addressing vertical movement during this period of study.
Yeah, so in the dye tracing test, you can look at different elevations. Monocles are different elevations to determine when they show up. So there is flow horizontally in that heavy karst zone between the overburden and bedrock, but there's also a vertical. Many of the injections that were done in heavy karst. I think this shows up in 2012 dye tracing before. Don't show up in the heavy karst. Again, they show the bedrock being their strong vertical downward gradients from the heavy karst overlying layers into the deeper groundwater for these flash, where the conduits were looking at these strange things.
All right. So again, we had a finding a minute ago or indication a minute ago of 7,000 feet in 50 days. We're now at doc 23178 at page 29. How does the reviewer, how do they address velocity, and what do they determine there after these studies in 2000, 2003?
Yeah, so the dye test, they basically, again, ignoring the dye test results that show connection to SB6, just came up with groundwater flow velocity based upon the data they gleaned or wanted to. Sort of the heavy cars around 10 to 13 feet per day. And the bedrock, around a foot per day. You can see that applies to groundwater travel time. Bedrock or order of magnitude less than you see in the heavy cars. Which is true if you might consider just diffuse flow, but they've ignored the common flow, which shows several hundred feet per day. Ground flow velocity. Again, ignoring the data.
How should that data have informed them and influenced the conceptual site model?
Well, I mean, obviously, the conceptual site model should have shown that their groundwater flows in the northwest. Probably just most likely radial extension. Groundwater flow velocity is the bedrock, although diffuse flow line is slow. There was strong evidence, compelling evidence of conduit flow, very high groundwater flow velocities, which should made them look at even further out and more dye tracing to determine what other springs might be connected to the site to be used for groundwater monitoring to detect contaminants, or at least as soon as possible.
All right, let's skip forward again. We're now at document 31843 on page 8. Now, put this in, just kind of give us an idea of where we're in the evolution of the information. But can you describe to us a little bit what was done during the next round of testing here, where we get these documents in 2005, 2006 with additional information?
Yes, they did do additional exploratory borings. They did some formal geophysics on required to some test pits, geotechnical testing with properties of the soil. Did the aquifer pump test, and then they did dye test number 2. That's what they're saying in EB 13 and LF1, which I believe was repeat. Because they thought there was some anomalous data in the LF that the testing did at LF, but I didn't.
All right, so can you tell us a little bit about how they conducted the 2005 test and where they were looking this time?
Yeah, so in the 2005 test, springs were monitored on purpose, and that's fine. And I'd like to correct Mr. Meister, who said in his opening that I discounted all the results of Dr. Brahana and Dr. Ogden, which is absolutely not true. In fact, this is work that Dr. Brahana did, where they were looking specifically at the connection between the northern part of the landfill, the expansion area at that time, and perimeter monitoring loads that they installed. And so springs weren't included as part of that. Now it says in Rule 22 supposed to include springs, but I think it's reasonable what they were doing, and they did actually find connections between dye injection locations and perimeter monitoring. They're currently being used for as part of the groundwater monitoring system, which are shown there on the perimeter north and east sides. So that, they were, that was very specific purpose to see if, in accordance with EPA's guidance on cars, that if you're going to use monitor wells for groundwater monitoring, this type of geology, that's what Dr. Brahana was after, that you need to show connection. And they did in some cases. And that's good.
All right, and so you said they did. Here's a summary. Generally what, if we need our map again. Well, I guess we just showed it a moment ago, but there's the transport times on those findings at document 31843 of page 71. And what do those transport times tell you in regards to the 2005 study?
Yeah, so we have, in some cases, we have, groundwater flow velocities on the order of 100 feet per day. For example, at WW 4W5, which runs the northeast part of the landfill. Some slower velocities at LGW 7, which I believe east side, and W7, which is south side. So higher flow velocities going northeast from these injection points, not south, which is the direction. Most people historically thought groundwater flow direction, and even like I said in 2021, there were still indications that the primary direction of groundwater flow was south. So dye test results, I think, did what it was supposed to do, show connections to certified wells. Again, fast flow rate.
Now we have appendix P to that study. We were just looking at the conclusions of, and we're at document 31845, excuse me, which is appendix P to the study. What are they concluding regarding the karst features in appendix P, document 31845?
Well, they say that the dye test reaffirms the conceptual model as part of the dual porosity system. The blast flow component in the epicars, which is the zone between the whether regolith material or clay material and the bedrock boundary, and then the low flow component being the bedrock. Well, that seems inconsistent with the results of the dye test, which showed actually groundwater flow velocity was higher in bedrock, and also evidence of solution conduit flow in the bedrock, very high flow velocities. The heavy cars is really that saturated zone, although groundwater flow velocity in some cases were high, not as high conduit flow. But that's just kind of an isolated zone. It's mostly in the southern part of the land. So I would disagree with the flow.
The continuation. You there? This is a continuation of 31845, page 6, appendix P. And this is the specific finding you were saying you disagreed from there. Slow flow components of the system are several orders magnitude less and are estimated in a range from approximately 0.5 feet per day to 1 feet per day. So again, is that what you were specifically discussing a moment ago?
Well, I think, well, they were saying the low flow.
Oh, sorry.
In that previous, what I would say, this one is that's correct. Last flow components are
Understood.
and the low flow. That doesn't distinguish. Heavy cars.
Understood. I apologize. All right. Are there any other findings from the 2005 era studies that we need to discuss before we move on?
Not that I can recall.
All right, well, let's move forward to the 2012 assessment. What prompted this work? or what was its purpose?
I believe it was, to look at the expansion, the flower expansion in the northwestern part of the landfill. You can see all those purple triangles or borings that they did as part of the geotechnical evaluation. They injected dye, into, locations there, all kind of in that area where the expansion being proposed. And then monitor quite a few locations, again, to look at connection, between, between different monitors or different wells, and the injection points. They also monitor some perimeter. You can see again that we got injections in that area, we got flow, injection type flows to the north, northwest, also to the south, southeast. So very well documented here, radial flow from the injection. And again, there is a monitor well, and I think that's also a monitor well there on the north side. That is part of the monitoring program. And I think it also shows connection to 5. But many of the monitor wells, are see here, they're on the perimeter, don't show that. They're not being monitored. To detect change.
And what, in addition to the monitoring wells, did they test in 2012?
So again, they tested springs, the same springs kind of we've been talking about. They're close to the facility. There was, and they also added one, I think, what they call the Steel Community Spring to the northeast. Again, the locations that showed connection to the dye test showed green, that showed a connection to what they call Clear Spring, which is directly southeast of landfill. They discounted because it only showed 5 of the 6 criteria. They called it a likely resurgence of groundwater from conduit flow. They said that it didn't have 2 detections in a row, but the time it was detected, they were only monitoring 21 days apart. So of course, you may not see that, if you've been monitoring more often, you would potentially see it 2 days. So that one they call it the likely one. Again, SB6 Farmer Springs showed a connection. They discounted that because with that 5 and 6 criteria. Ignoring the results from other dye tests that all showed a connection.
Got a few documents that were produced as a result of the 2012. And so we'll go through those for a few moments. Talk about some of the new statements that were developed. Why are we highlighting document 64882 at page 8 regarding the components and their discussion thereof? Why is that important to this study?
Well, I think this is the restatement of what's kind of been known previously, is that they're kind of looking at 3 zones. This overburden clay zone, which really doesn't have any water in it. The Eco-Vista, which is the high weather rock zone above the bedrock, which is primarily located in the southern part of the landfill, and then of course they have the limestone. It does have a church. So, consistent with kind of their previous discussions of different strategies.
Paragraphs follow. We're still at document 64882 at page 11. Can you tell us what discussion there that's underlined and what they're discussing there in regards to groundwater flow at the site?
Yeah, so based upon the work of that dye test and some of the borings they had done, they recognized at this time that the southern part of landfill did have this Eco-Vista, which is kind of non-existent or only had limited presence of the northern part that there was, and in that zone, there was what they considered to be lower ground flow loss than bedrock. But they also recognize that there were significantly higher ground flows. Next slide. In the northern portion. Yeah, so they determined, based upon that data, that the majority of groundwater flow in that southern, northern part of the lateral expansion, which is very close to the recent the class 1 expansion area, has a radial flow as opposed to southerly flow in the southern part.
Yeah, and that's a recognition in August 16th, 2013, document 64882, page 11 of a radial flow. All right, and these are some of the specific findings. We're at document 66023, page 7. Can you tell us a little bit about what was found as far as transport and direction? Here, again, document 6602 at page 66023 at page 7.
Right. So yeah. So looking at their results, where they injected versus where they detected, 3 indications here of northwest flow, not southeast flow. You can see again, 1,000 feet, 50 days, 700 feet, 10, 12 days. These aren't, they're not exact groundwater flow flows because in some cases they do flush water after injection, but they give you a rough idea of the magnitude of groundwater flow. The velocity is very high in these where you see in the bedrock, especially now we're up in the northern part of the landfill where we see groundwater flow to the northwest.
All right. There's additional findings there. On the northwest and the west flow, still at document 66023, page 8. We also have a velocity statement there on that last bullet point. Can you tell us a little bit about what that distance and the offsite spring discussion tells you?
Right. So this is where they're talking about the detection they had in Harvard Spring, SB6. And they're saying it was consistent with the regional conceptual model of groundwater flow and an anomalous valuation of previous diagrams. Is correct. And that the groundwater flow is around 7,000 feet in 61. So consistent with what we consistent with what some people at that time considered to be the model. And consistent with prior dye tests, which showed connection between this landfill and Harvard Spring, dating all the way back to 1996.
All right, Your Honor, may we take a short 5-minute break?
Sure.
All right.
All right, we're off the record for 5 minutes. All right, folks, we are ready to proceed. We are back on the record. Please continue, Mr. Nolan.
All right, let's move into the last round of testing and investigation prior to the issuance of this permit. Can you tell us a little bit about what was being investigated beginning in 2020 at the Eco-Vista site?
Yeah, so they're looking for this lateral expansion. So they're looking through the Rule 22 requirements. One of them is to look at aerial photographs and different items to look at. Bedrock lineaments, tractor traces, usually to be some preferential alignment orientation to that, to the lineaments, which you can get an idea of where you expect flow to occur. In this case, most of them oriented northwest southeast, and so that's consistent with kind of what we've seen today or digest studies. You can see flow to the south, southeast, and also
All right, and that, excuse me, was a lineaments trace survey from the hydrogeological investigation summary report, July 20th of 2020. And that's document 78620. All right, let's talk a little bit about what the dye study in 2022, its purpose and what it discovered. Can you tell us why they conducted that dye study?
yeah, so they were looking at the, I think this is actually the class 4 expansion. So they excavated a trench. In this case, they didn't use monitor wells or designer that actually excavated a trench down to the top of the bedrock and put dye. The dye test work plan did not include monitoring of any springs, as they said. Previous results had indicated that there was no utility in monitoring springs during dye tests, based upon the previous tests.
Okay, we'll get there in just a moment. So yes, tell me, the document 78620 was the summary report, and then that led to the dye trace study work plan that you just mentioned, December 13th of 2021. And of course, that resulted in a dye trace summary report dated June 5th, 2023. So let's walk through those a little bit. Tell me what the understanding of the conceptual hydrogeologic model was in July of 2020, and we're at document 78620, page 54.
Yep. So again, we see that the three kind of units, the three strata that we talked about, the residuum, the clay material.
Yep. Sorry.
And the limestone, the weather residuum there, it's in this case, it's referred to as both the regolith clay material and also the parts. Got the aquifer that they plateau aquifer, which is information discussed, which has both limestone and eternity limestone. It's a karst system. Developed with discontinuous heavy karst. And they say with few exceptions, water bearing fracture compressed almost 20 feet of bedrock. And then groundwater also this bedrock interface in this heavy karst. It's just continued.
All right, and here we're still on document 78620, page 54. Are there additional observations there we need to make before we move forward to what happened in December 2021?
Yeah, so they say that groundwater in the Regulus and cars has a flow velocity of, around 1 to 6 feet per day, which we've seen in prior, and it's the direction they did in prior studies. Direction of flow is controlled by bedrock into the south. That's consistent with prior studies and my understanding. Well, but then they indicate that the groundwater, the limestone, and insured bedrock has a velocity of less than a foot per day to a foot per day, which is lower than that in cars. And that the direction of flow is bedrock, shallow bedrock, is to the southeast, similar to the groundwater free. And then deeper wells in the bedrock indicate flow to the northwest, northeast, southwest, south. The rate that seems to be fair, I do not agree. Flow loss based on
Okay, and so what, and we're still at 78620, page 58. What did this report call for?
so that indicates that a dietary study will be part of the permit application for the class 4 expansion. And the findings from that new study will be used to update the conceptual hydrogeologic from 2030.
Okay. We are at document 81172, the dietary study work plan, December 13th of 2021. What has changed between the 2020 documents and the 2021 document that we're looking at here?
Well, for these bullets, not much. Again, we've got the Springfield Plateau Aquifer, but on these bullets, for some reason,
And I'm sorry, I've moved forward once. We're still at document 81172, December 13th, 2021 dietary study work plan. And this is page or section 2.3 entitled Existing Site Conceptual Hydrogeologic Model. I'm sorry, I interrupted. Just wanted to make sure.
well, yeah, so everything kind of above this last paragraph is pretty much saying between the 2022 application and this dietary program. But in this data test study work plan, they changed the conceptual site line to indicate that the deeper wells were reported to follow a different pattern than is the southeast, with flow to the northwest, northeast, southwest, southeast. However, this conclusion was based on data that did not meet criteria for positive dye testing. Positive dye detections were other data anomalies. Well, that's not true.
Tell me specifically why it's not true and why you're critical of this statement in the 2021 document 81172.
Regardless of what you believe about whether there's detections in the spring or not, prior to this time, the dye test clearly showed there were multiple directions of groundwater flow, bedrock up, fast conduit flow, northwest, west, not just the southeast. For some reason, and this is the latest conceptual hydrogeologic model for this site that I have found, indicates that the bedrock groundwater flows to the southeast, and that these previous directions that were determined based on all the other dye testing today that showed radial flows, multiple directions of groundwater flow is wrong. That is going to the south. And that the overall sideway direction of flow of the limestone is towards the southeast, which is not available today. It's just simply not correct.
And to your knowledge in your review, you said this is simply not correct. Is that also the most recent conceptual site model that you can identify in the record?
Yes.
Okay, after that, from that plan, we, there was then an actual dye trace study conducted, and I've just included these dates here to orient ourselves. This is from Doc 83386, page 5 of the dye trace summary report. Let's talk a little bit about what was actually found there. What were the results of the dye trace study? And we're at Doc 83386, page 10.
Well, the results of the dye trace study indicated that none of the monitoring wells they were monitoring on the site, which is the only place they were planning on monitoring, because they indicated in their site tests were planning. That was futile, that there were no indication in prior past dye tracing studies that there was a reasonable likelihood or reason to test the sprinkler stream. So they didn't test the sprinkler during this dye test. What happened was somebody noticed, resident noticed, dye in the creek at Orange Springs, SB6. And then they started monitoring. So, and that was about 2 weeks after the dye test. So roughly 6,000 feet. Okay. Less than 14 days or less. We don't know exactly when, because they weren't monitoring. It wasn't part of their dye testing plan, because they discounted every prior result that showed potential for a connection between this landfill and springs, and discounted the guidance that says this is where you need to monitor in the spring.
All right, so we are at document 83386, and this is the dye trace summary report conclusions, and you just alluded to it, but how fast was the dye moving away from the facility? What would you characterize that rate of transport?
I think 6,000 feet in 14 days, around 400 feet per day. Calculation, right? So again, that's some of the that's probably the highest flow velocity we've seen to date in this dye test. So again, hundreds of feet per day, just not close to not inconsistent with what the recent job would tell us about. In part.
All right, and what is the first bullet point up there? What is the direction of flow indicated by this study?
That the groundwater flow is horizontal northwest from them, which is the direction of the spring, consistent with the direction of the pressure from the class 4 to Wildcat.
Okay. Let's return to the regulations and discuss state of the conceptual site model versus the dye trace study conclusions and the timing of this permit. So if you will pick up 22.1102 B1, I guess I should say, are you aware that this permit application was made in July of 2021?
That's my understanding. From the application.
And again, when was this dye trace study conducted?
2022.
So that is after the time of the permit application. Is that right?
Yes.
Okay. And again, one more time, since we're going back through it, when was the last conceptual site model that you can identify in the record?
It's in December 2021 dye trace study.
All right, so let's look at 22.1102 B1. Is there a conceptual hydrogeologic model of the site developed, which is informed permitting decision that's before us now?
There was one that was developed, yeah.
Was it accurate?
Yeah.
tell me specifically why it was inaccurate.
Didn't aggregate all the historical data from the previous studies that showed high ground flow velocity, conduit flow of bedrock, multi-directional ground flow, not just in the southeast. Radial flow.
I'm sorry, Mr. Nolan, what rule are you looking at?
We're at 22.1102B1 right now.
All right, I thought so. I'm with you.
And then I want to move, well, and we got off track for there for a moment. I didn't want to interrupt you. Again, why was this permit application not informed by a conceptual hydrogeologic model of the site developed? A developed conceptual hydrogeologic model.
Well, the latest conceptual hydrogeologic model indicates that the groundwater flow bedrock primarily to the southeast, low velocity. That's not correct. High velocity, conduit flow in bedrock in multiple directions, radial flow, consistent with regional geology, consistent with what we've seen. Work that Dr. Rahana did in the area, work that others have done in the area that show radial flow, distal points for fast conduit flow to groundwater to springs and streams that are distant from the location where the injection occurred in this case.
Let's also look at 22.1102C2, which calls for site characterization. Specific geology shall be defined through field investigations and includes springs and seeps and domestic agricultural and municipal water wells. Was the site properly characterized in regards to springs and seeps and water wells?
In 2019, for the first time I've ever seen what is alleged to be despite to a survey of springs and seeps. They identified 16 additional springs that had never been identified prior to them. Never were sampled as part of any prior diaries tests, including that done.
We'll go through those in a moment. And I guess this is a similar question as to the B1, but in regards to 22.1102D, can you find in the record a true summary report where all information has been integrated into a comprehensive hydrogeologic model as required by D?
And not see one in the most recent permit.
All right. And let's look at 22.1102E. Common permit application was there, and I'm looking at E1, a detailed surface mapping of all karst features.
Not seen that. Most of them say there are no karst features. Yeah. Look at fire. Look at fire studies going back to 97. They say there were sinking stream. Sinkhole in the area.
And E4 calls for groundwater dye trace study, which we just looked at one from 2022, the results published in 2023. We'll put those results back up there. Document 83386 at page 5, the dye trace summary report. Have these conclusions, which are required by E4, have they been incorporated into a comprehensive geologic model that you can identify in the record?
the 2022 dietary results that I.
They have not been incorporated into a model
Right.
that you can identify.
Right, again, latest model says groundwater flow to the southeast. Low velocity. But I don't know. That's back, so previous conceptual site model. Except it says there might be some connection between the area of class 4 land. But I would argue that the data shows a connection between this entire length of number of springs. That's based upon all the data that's collected.
We will come back in a few minutes to what a good conceptual site model would be. I'd like to look at 22.407. First. All right, so we're at the bottom of this page, but 22.407A. Can you please read the second sentence there, starting with the owner?
The owner or operator must place demonstration in the operating record, notify the director that it placed in the operating record, provide the demonstration to the director for approval.
Guess I should have started you at the first sentence. I left a little out there. Well, I'll do it for you. Owners or operators of new units, existing units, and lateral located in an unstable area must demonstrate that engineering measures have been incorporated into the unit's design to ensure that the integrity of the structural components of the unit will not be disrupted. And then those records must be in the operating record documented. Let's talk about a few observations that you've made in regards to unstable areas. What has your review of the record indicated regarding unstable areas?
There is indication that there are unstable areas, by definition. Part of terrain are together potentially stable. There. Result of dissolution of underlying bedrock, which results in sinkholes, collapse of earth. So, certainly there's indication that there are some unstable areas in the area of landfill, in the landfill itself, based upon not what we've seen. That there were some, you can see here, there are some sinkholes. It's the 1970 topographic map identifying that there were some sinkholes in the area of the landfill that are associated with collapse features. But then there also have been some discovered during the.
Well, let's look at the map for a moment. Can you identify what's in front of you there?
Yes, these are topographic maps, United States Geological Survey topographic maps of the province and Arkansas quadrangle. First one, and this second one is from 1970, which is just prior to the operation of landfill.
All right, and when you were reviewing this map, as part of your familiarizing yourself with this property, what did you observe in the area of the landfill? And if you turn to the second page, we've got a close-in of what the bottom right corner of the first page, or the south east corner of the map.
Right, so that So this is the southeast corner of Robinson Quadrant, topographic quadrant. Created landfill and all the presentation up there. And you can see that there are a number of karst features, which are these small round dots that don't have either inflow or outflow. That's not the classic definition of a sinkhole. That is, they're not dead water from somewhere like a stream, they're not discharging from a stream like a pond. And so you can see that there was a very large sinkhole right in the area of landfill. Last one landfill area, and then there's several over here in the last west side, from the side.
All right, can you draw an arrow to the large sinkhole and label it number 1?
All right.
And then if you'll please draw an arrow to the 2 smaller sinkholes that you observed and label those 2 and 3.
Okay.
Again, I think we said it a moment ago, but what does this indicate regarding the nature of the area of exactly where the landfill is located?
Well, that there were, reader body reports said there's no evidence of single in the area of this plant. Well, sure it was in 1970. Landfill was built on top of. And so, it's an indication that there could be underlying stable areas, or that that at least there's potential. It does have a big residual layer that there is potentially that there are other signals, other collapse features that maybe did make it surface that aren't.
Got our asked at this map. Mr. Hart marked up locating sinkholes. Topographic map be admitted. Just shows the exhibit 6.
Can we get copies of that made? If that's the only copy, they need to cross or whatever. First, let me ask, is there any objection to the admission of petitioners 6? All right. Why don't we go ahead and, without objection, petitioner 6 is admitted. When we have a break, why don't we go ahead and have copies made? So that way everybody has a copy.
Thank you.
Please
John.
proceed.
All right, we've done a lot of discussion about dye tracing and understanding the topography of the area. Are there any indications in the work that's been done there that there are unstable areas in and around this landfill property?
Yes, I think, believe in 1999, there was reported voids found while they were constructing a landfill. I think they said it was 12 feet long by 2 to 3 feet in width. At the base of the landfill, they did go excavate back, but there's certainly evidence that if they had found that, they could have collapsed. Construction didn't form after construction of the landfill. It also was I think it said for 2001, while they were doing support for the expansion of the West for facility that they had a collapse occur while they were boulders were leading up in this area. I believe that other 1991, not exactly sure whether it was somewhere. I think of this area when they were prepping the foundation or the base for the platform
And
expansion.
can you tell us again where the record that 2001 cave-in was documented?
2001 was an affidavit from a gentleman that worked at the landfill. I think there was concern that there was reports believe that there was a collapse in the landfill. And it may have referred, that may have been referred to 1990. Collapse or collapse, whatever. But the indication was from the affidavit that collapse that occurred in 2001 was just outside the class 4 landfill area. They were putting in a good miner.
In regards, oh, sorry, is there anything else we need to add about the collapse area? None so far. Okay. In regards to the dye tracing and the understanding of the facility, the land that it lies on, do dissolution features go into your concern or analysis regarding unstable areas?
Yeah, I mean, there's certainly concern that there could be unstable. I don't think we look through the entire record to see there may have been other instances. I honestly just kind of stumbled upon these in the record. But certainly, if you're going to look at unstable areas, you have to consider that this is an area that's sparse and its potential for significant voids in collapse features. Because it is.
All right, we are at document 80454, which we have visited many times today, but page 28 of the permit modification application. It states up there are no evidence of areas susceptible to mass movement, and that any voids within the bedrock would be small and would not create unstable condition. What is your assessment of the likelihood that is in fact the case?
Well, it's interesting because in the same report, they discuss a void that they encountered that was 12 feet long, by 2-3 feet width, but they're saying that all voids are small. I think they did model a small collapse. I don't think it's as big as 12 feet long by 2-3 feet wide. What that would do, that basically by proof rolling those small voids, they would collapse during proof rolling bottom of the land. I don't know that they model a large.
Well, considering these things we've just reviewed, the collapse, some of the records that you've just stated, is there a demonstration in the record, in the operating record, represented by this paragraph that all unstable areas have been accounted for?
No, I have not seen it. Most of it, rather than doing current analysis, just refers back to the 2002 geosynthetic. Says, oh, we determined there were issues, unstable areas based on that. Rather than looking at what's determined since that time. Own evaluation, whether there are speed.
So there's been a gap of 22 years since the last attempt at demonstrating in the operating record compliance with 22.407. And I'm sorry, what was the date on the geosynthetic report that you just referred to?
2002.
Again, so there's been 22 years since there was a demonstration in the record regarding unstable areas. Is that correct?
That's what it looks like to me, especially for the most recent.
All right, thank you, Mr. Hart. Let's move into groundwater monitoring for a few minutes. And do you still have 22.1102 in front of you?
Yes.
Can you please refer to 22.1102B3? And read that and please tell us what that means to you.
Market well location design of facility monitoring plan must be capable of detecting landfill derived water chemistry changes as soon as possible. That means to me that your plan for monitoring needs to be able to detect changes in chemistry as soon as possible. So that you have groundwater flow velocities in the range of 100 to 400 feet per day. Your quarterly monitoring program. Yes. Especially monitor flows. Well, monitor flows that haven't been shown by the trace study are basically irrelevant. They're just monitoring, quite frankly, a waste of money. And giving false sense of security. The ones that have shown a connection. Quarterly may not be enough. Then they also are not monitored, well, they're monitored one spring now, but historically they're not monitored any springs, and continue not to monitor any other spring, despite indications that there's connection in the springs. I'm not saying you have to stand fund, but something like evaluating and consistent with the guidance, might monitor baseline condition, but also monitoring during storm or meltwater events. So that you're not, you don't have to go out there every week, and do something, right? But you do it when you have the likelihood of detecting something, most likely of detecting something, which is the most potential flux in this company's landfill, which is stormwater.
Well, let's also look at 22.1202, which is chapter 12 of Rule 22. And if you'll look at 22.1202A there, it states that groundwater monitoring system must be installed that consists of a sufficient number of wells installed at appropriate locations and depths to yield groundwater samples from the uppermost aquifer. Tell me kind of what that means to you, and then we will get into the specific groundwater monitoring plan.
Well, yeah. So of course it's different, right? I think people have to have fundamental paradigm shifts in how they view groundwater monitoring cars, which is the whole point of the 98 document, was that you can't treat this like a regular facility where if you think groundwater is going to the northwest, you just stick it in monitoring. That's what happened at the most recent guidance. Not only was monitoring spring, but they just said we're going to install 4 more wells. Well, they don't know if those wells are connected at all. So those wells are connected. You have to, if you're going to use monitoring, you need to show that they're connected by diagrams, which is what Dr. Rahan did in 2012. That those monitors that you're using are connected to hydrogeology.
All right, so let's keep that in mind for a moment and look at document 80454 on page 65. And, at first blush, this states we have 43 wells monitored at the landfill. Tell me the breakdown of those wells and how that relates to your statement that you have to prove the connectivity to make them useful.
Yeah, so they're monitoring 23 wells for their landfill monitoring. I think I identified 6 of those wells that should that showed either a definite connection or a potential connection to titration study. So I'm kind of saying even a potential connection to be at this point is probably okay, great. But we've got 6 wells out of the 23 that are monitoring that show a connection to the karst conduit flows beneath this land.
And can you point to those on the aid there and identify them by name? It's a little fuzzy up there on the screen.
I believe it's LGW2, LGW4, LGW5, LGW7, Article 7N, MW7N, and I think MW1N. So all those are located 1 west, 2, 3 northeast, couple of east, but nothing in this area. And again, other than the 1 spring, not monitoring any springs at all.
Okay.
which quite frankly, the springs may have probably have the highest potential, but to have landfill drive chemistry is possible that we've seen the results. Digest. Trace testing as well as previous.
All right, so let's be real specific. You hit it a moment ago, but why is it that those 6 wells you identified are the only ones that are doing the work here?
Those are the only ones that have shown connection to the bedrock flow in below land.
All right, is that Search 22.1202 a sufficient number of wells installed at appropriate locations?
In my opinion, no. Needs to be more wells. If you're gonna use wells, you're just gonna randomly install them, and you've got to show a connection. More recent wells that were installed based upon the results of that 2002. No dye tracing has been done since then to show it. They're irrelevant really to monitoring. There needs to be more monitoring wells installed. And they need monitoring springs. Come up with a monitoring program that meets the criteria. To detect contamination, landfill drive chemistries.
What would water wells also be a good addition to a monitoring program?
Absolutely, well, it would be good if they're again going to be connected through dye tracing to the land.
Yeah, hold up here. Let's talk a little bit about the 2019 study that you referenced a minute ago.
If we're looking at the July 20th, 2020 geotechnical and hydrogeological investigation summary on the PowerPoint, and Mr. Hart also has a board there. What did they determine and discover in regards to water wells during that investigation?
Well, 2019, they kind of did a 2-pronged water supply well survey. First one I've seen from. They initially did kind of a desktop survey to look at records of water supply wells. And then they also sent out notices after that to property owners within a half mile to determine if they had a water supply well and what was being used. And so I think in the initial part of the survey, they picked around 100 or so, and that was a much larger radius. But in this half-mile radius, I think they had around 50-ish wells that were either being used for domestic purposes or for some other purposes like irrigation. And then they also had 2 springs that were used for drinking water south of the site. Which was concerning to me.
Right, so we've got
all concerning to me, but especially the springs located south of the site, which is like last spring.
So let's look at the board at the PowerPoint. We're at document 79709, which is page 2. Results of the water well survey. You were just mentioning some concerns. Can you relate those to what the findings are here in regards to the responses to that survey?
Yeah, so this is again, and that was the results that we were just looking at, the survey that was sent out. So 22 properties or responses indicated water supply well spring used for domestic drinking water or brushing teeth, washing dishes within a half mile. And then 26 indicated that they have a well on a property that is not being used for drinking, but is being used for some other purpose. So, large number of wells, number of them being used for drinking water. They're located in the vicinity of landfill that's in a harsh area around the football center is a concern, especially to people during that spring. Go are very likely potential locations for groundwater discharge.
And are any of these being monitored pursuant to chapter 12 of Rule 22?
Not important.
All right, let's talk about a little bit of the findings on seeps and springs. We are at document 78620, page 55, and you alluded to this earlier, that this was the first time that certain karst features have been identified. Could you tell us a little bit about that?
Well, you know, all the previous studies, you're supposed to identify all the springs and seeps within the vicinity of the site. They only identified the ones that we talked about before, use those in some of the diagrammation. 2019. Eco-Vista, Salt went out and identified 16 additional springs. There's somebody, I don't think the spring just appeared, seems. So somebody, they were missed. And so none of those springs or seeps have been involved in any prior diagrams. And it also weren't included in the 2022 diagrams.
And have any of them been incorporated into monitoring?
No. The reason given that they weren't tested during the 2022 diagnostic study is they weren't downgrading the land. They weren't southeast of the land. Consistent with what they believe is the hydrogeologic model. The groundwater only flows to the southeast of this land, despite all the data to the time.
Let's take a look at a little bit of that reasoning over the next few slides. This is document 81172, which is page 17 of the dye study work plan. And this is what you were alluding to. What does that first sentence there say?
No previously identified springs or surface water bodies were selected as monitoring points for this study because dye traps installed at spring and surface water locations are an uncontrolled environment where they're exposed to variable environmental conditions, possible causes of damage. Such the validity of results from such locations is questionable, as shown by prior studies that this. The lack of use of dye detection monitoring tools. Previous dye study reports indicate spring and surface water samples associated with the Eco-Vista site cannot reliably produce representative hydrogen samples regardless of the season.
Okay, let's break that down. First, is it good practice to exclude springs or surface water bodies because they are exposed to variable environmental conditions?
No, that's why background studies were done before dye traps, and you put them out ahead of time to see if there's background fluorescent or some other concern that would interfere with the results.
And let's also look at, oh, thought I had the table for 3.2 in there. I do not. Last slide. What does table 3.2 represent there? And what issue do you take with that?
Table 3.2 has a summary of, very simple summary of our prior dye testing results. Every time it asked whether there was an indication that there was detection of dye in the springs or springs monitored in the prior dye testing studies, it said no.
Is that accurate? Is that an accurate representation of the data available?
No. This did, and within 14 days after this dye study was done, this statement is approved.
And to your knowledge, has any of that information that was developed subsequent to this used to update a site model?
No.
What about update a monitoring plan?
Only thing they did was add Harmon Springs and install 4 water wells on the northwest side of landfill option through dye testing.
back up for a moment and we'll come back. Let's talk a little bit about the site model. What in this situation work would need to be done to prepare an actual comprehensive geologic site model?
think you can start with going through all the previous information that's required. More about crop protection, dye tracing study. If there's some concern about a dye tracing study that was questionable, so then indicate that. You can't just say no, there's no indication that there was a connection. There's clearly connections shown in prior lectures. And then you need to develop a dye tracing study that incorporates monoclines here, the springs out here, some water supply wells in the area, to get a handle on what locations should be monitored, and which ones can detect contaminations. Then you should be able to develop a conceptual site model, groundwater flow, where it's going, where it's daylight, how fast is it going, all that information. And looking at studies about sinkholes and streams, what was detected in 1997, everybody said no cars topography, no evidence of cars. Well, 1997, they said there was a single stream here. There were sinkholes. You can see it on the topography. All of that information looked at, do updated data studies to come up with a hydrogeological model that is accurate.
And what would the work product be? What would the final conceptual site model look like?
Well, describe where the groundwater is coming from, right? Where it's discharging, how fast groundwater is going. And it would also include typically, here's the locations we recommend, just like we saw in Dr. Ron's recent study. Here's what we recommend. Necessarily sample every site. Here's the locations that we recommend sampling based upon that updated, accurate hydrogen.
And how would you use that model to inform monitoring?
Well, obviously the model tells you where things are going in the hydrogeologic system, so that's where you monitor. And how often you monitor, when you present monitoring wells that have no connection to this landfill or the basis. Well, it makes no sense. It gives people, like I said, false sense of security in this landfill. I'm not saying it has, but it needs to be monitored correctly and accurate. To detect those changes that may occur in the future.
Is the current monitoring plan designed to detect landfill-derived water chemistry changes as soon as possible?
No, not needed.
And pursuant to chapter 12, I may have asked you a moment ago, but is the number of wells and their location adequate to monitor the site?
No.
No further questions, Your Honor.
Thank you, Mr. Nolan.
Maybe you have a brief reasons.
Sure. How brief, Ms. Thompson?
Just what, 5 minutes?
We're off the record until 4. All right, you all set?
Yes.
All right, we're back on the record. Ms. Thompson, please proceed.
Mr. Hart, again, my name is Lisa Thompson, and I'm going to apologize in advance if I skip around because there's a lot of information that you covered. And I do have questions, but I have them in all the different areas. So,
That's fine.
and I have documents, so if I break away for a minute, I've got some extra documents over here on my table. I think the last time that we met, Mr. Hart, was during your deposition. I believe, even though it was it was online, I believe that was the last time we met, and I think that was on December the 4th, if I'm right.
Sounds about right.
Okay, yes, sir.
Early December.
Yes, sir. And at that deposition, I had asked you about your business, Hart and Hickman. And you had told me that you had been studying, you had been a geologist, a hydrogeologist for over 35 years. Is that right? Correct. Okay. And that you had performed testing in karst terrains. And I believe we talked about North Carolina had some karst terrains.
Yes.
Yes.
Not much. So,
Yeah. And I see from your list of your cases in which you were deposed, the Boone County case that you were deposed in, that was the Bland et al. V. Petromark et al. Case. I believe that was the DM Petroleum case. It was a regulated storage tank. It may have been an AST case. And there had been some petroleum that had gotten into some drinking water wells around the Harrison area. Do you remember that? That was like 20 years ago.
yeah.
Yes.
Thank you. Cold storage, believe I think they had about next Canada.
Yes, sir. Yes, sir. And a lot of the cases on here, and you can correct me if I'm wrong, but your business, you do a lot of cases having to do with regulated storage tanks and third-party matters. Isn't that correct?
No, I mean, they've done a number of them, but not a lot.
Okay.
Both of my experience associated with large industrial facilities. So,
And PFAS, I saw that as well. PFAS. All right. And I saw on your website as well that you had done a study of, I believe it was multiple landfills in North Carolina, like 9 landfills. I just briefly looked at your website, your Hart Hickman website.
I think that was the PFAS leachate study we did on PFAS.
Yes, so that was involving PFAS. And the one
So it doesn't seem, hasn't started breaking that, looking at it.
is the Boone County case. Boone County has karst terrain, is that correct? Okay, and so in that case, you would have more than likely used Commission Rule number 12, which deals with regulated storage tanks. So you didn't use Rule 22 in that case, did you?
No.
Okay.
Yeah, looking at hydrogel. And source of contamination, water supply wells. In this part of the area as well as the coast.
All right. And do you remember during your deposition that you testified that I believe this was the first time that you've ever applied Rule 22 to a landfill in Arkansas? Is that correct?
Yes.
Yes. Okay. But that you had expertise in reading the rules based on your 35 years of experience.
Well, certainly, I mean, anytime we take up a new project or part of an existing project, to the extent that it's associated, whatever it is.
Yes.
Clean up the groundwater lines. Start certain work. Many states across the United States.
All right. And you testified that you were not an expert in Class 1 solid waste permit writing, correct? And that you were not an expert in engineering, correct? Correct. And that, let's see. So let's start by talking about the dye test. Let's just start with the dye test. Actually, I changed my mind. Let's go ahead and start with the conceptual site model first. Now, in your review, I know that you reviewed a whole bunch of documents, and you did review the final permit. Is that correct?
Yes.
The permit application summary, which is on page 3, and this is the final permit, under the groundwater section, basically states, one of the first sentences it states is that the facility is located on the Springfield Plateau Aquifer, which regionally has good water quality, and that groundwater flow has been documented at the site with the highest velocities measured over several hundred feet per day. Do you agree with those two sentences?
Yes.
Major groundwater flow is concentrated along zones of secondary permeability, and the potentiometric surface interpretation and the dye study results suggest groundwater flows from the topographic high at the site. Do you agree with those sentences? If I may approach Your Honor, just have him.
Absolutely.
Let's do that. Let's do it that way. I would ask that you, just for time's sake, go ahead and read.
Starting at major, the whole thing.
Yes, sir.
Major groundwater flow is concentrated along zones of secondary permeability and measured surface interpretation. Study suggests groundwater flows from the topographic high of the site. So the site as a whole flows primarily to the southeast with the northwestern part of the site along the west. Conceptual model for groundwater flow at the facility is best described as the full porosity groundwater flow system. Groundwater flows with generally slower velocities for small fractures with solution pores of discrete transport large volumes of groundwater sometimes at very velocity. These discrete are not discrete. Some may be just above groundwater table. So
Is that it?
whether the sense at the end, space and that the groundwater facility has had an impact to facility operations in its correct fashion. Select from at this time.
Thank you. So I present to you that that is the most current conceptual site model that DEQ has in the current permit. And do you, what portions of that do you not agree with?
I don't think this conceptual might be allowed.
Oh, you don't? Okay, why
It's a
not?
summary,
Okay.
but it's not conceptual.
What is he reading from, Ms. Thompson?
This is from the
Exactly.
actual permit. It's the permit application summary, page 3 of 11.
Thank you.
They're saying they can hear you fine.
Lights on, oh, sorry. Sorry, there's a green light and there's a really green light.
Moment. Let's move on to the dye testing. Let's do the dye testing next. All right. In chapter 22, chapter 12 of chapter 22, you testified regarding, and I have so many things here to look at. Let's see. You testified regarding 12, it's right here. And Your Honor, I may be getting hypoglycemic. I may need to grab a snack real quick. If my co-counsel can grab me a snack, would that be okay?
That's fine.
Okay. Because I can't, I'm having a hard time thinking straight and looking at my notes.
Understand.
Okay. I apologize, and I normally can think straighter than this.
Whatever you need to
Uh,
get yourself prepared, Ms. Thompson.
Okay. I apologize, Mr. Hard. Okay, in chapter 11, regarding the geotechnical model, it talks in, under E, the Boone St. Joe Aquifer of Northern Arkansas. It mentions in E4 that you discussed during your, direct testimony. E4 states that a groundwater dye trace study shall be performed to test the accuracy of the site's conceptual hydrologic model. So there's only one is required per expansion. Would you agree with that in Rule 22?
And only,
It just states a groundwater dye trace study shall be performed. It doesn't say dye trace studies, isn't that correct?
yes, but a study it includes certain different components of the study.
Correct, I
We could
understand.
say we're gonna follow up if we see something.
I
It
understand.
doesn't say you're just done after you do the study if you have inconclusive results. It also says that you're supposed to develop your conceptual hydrogeologic model and then perform your dye study, not perform your dye study and then develop your conceptual hydrogeologic model, which has been done throughout this process.
Are dye trace studies expensive?
Yes, it's very expensive to have a landfill and carbs train and do groundwater monitoring. That's laid out in the EPA protocol. It should be expensive. The protection of human health and the environment is expensive.
Yes. When you prepared your report or developed your opinion, I'm sorry, did you look at Rule 22 .424 regarding the point of compliance under D. It's on page 4-17 of our Rule 22. Rule 22.424, minimum design criteria.
I've read Rule 22. I don't have it in front of me, but as I recall that I at least reviewed it.
D, the point of compliance basically states that the relevant point of compliance specified by the director shall be no more than 150 meters from the waste management unit boundary, shall be located on land owned by the owner of the municipal solid waste landfill unit. In determining the relevant point of compliance, the director shall consider at least the following factors: the hydrogeologic characteristic of the facility and the surrounding land, the volume and physical and chemical characteristics of the leachate, the quantity, quality, and detection of flow of groundwater, proximity and withdrawal rate of the groundwater users, the availability of alternative drinking water supplies, the existing quality of the groundwater, including other sources of contamination, and their cumulative impacts on the groundwater and whether groundwater is currently used or reasonably expected to be used for drinking water, public health, safety, and welfare effects, and practicable capability of the owner or operator.
Is there a question?
Did you review that? You said that you reviewed it, correct?
I'd have to read. Can you show it to me?
Sure.
I don't have it memorized.
I totally understand. I have not memorized Rule 22 either.
Okay. So a point of compliance. What is, my question is
My question
rhetorical, is what is the point of compliance for this landfill? A single point of compliance for this landfill.
how would you interpret that?
I don't know how to interpret it.
In regards
Because it seems to be
monitoring-
in conflict with what it says about titration results, that you need to monitor springs, streams and other things, which clearly, in my opinion, are not going to be relocated necessarily on the land.
Exactly.
And if there's only one point of compliance, why are they monitoring 26 monitor wells? Why not just monitor one? If you only have to do one point of compliance,
Would,
why are they monitoring a spring right now?
would monitoring the seeps and springs then be more of a nature and extent?
No,
You don't
no,
believe
if
that?
they first dilate, if your first detection, you have to detect contamination per Rule 22 as soon as possible. And that's what it says. In your monitoring program has to detect your landfill derived chemistry as soon as possible.
Does Rule 22 define what as soon as possible means?
Not specifically that I'm aware of,
Doesn't.
but I think everybody knows what as soon as possible means. That's as soon as possible.
But
It
wouldn't the
doesn't say
liner, I'm
what.
sorry, wouldn't the liner system of the landfill though, wouldn't the liner system be what would catch any kind of leakage of leachate as soon as possible?
No. If it's intact, potentially, but you monitor leachate, but then I mean, what's the point of groundwater monitoring? If you're gonna say there's a liner there, there's no reason to monitor groundwater.
Well,
If you're saying that the liner precludes any potential for groundwater impact, why is there a provision to monitor groundwater?
Rule 22 requires groundwater monitoring at landfills.
Right. Absolutely. So are the rules in place just to check a box? Are we here for protecting human health and the environment? That's my question about this. Like, we do a spring and seep study and a water supply well study just to check a box? Or are we concerned about the people that are drinking the water and the springs in the area? To me, it's important to distinguish that. It's not just to check a box.
Your Honor, I'm not asking the witness a question at this time.
Well, he's responding, I think, to
I
your
understand.
question. Yeah, go ahead.
I understand. Would you agree with me that monitoring springs can be difficult?
monitoring the springs is, I mean, it can be difficult, but there's certain procedures in place.
Would you agree that dilution of any release that occurs in the spring or stream prior to sampling would make that difficult to sample that?
That's why you sample at the spring.
What about not knowing where the contamination is from?
That's what dye tracing tests the results to show that there's a connection between the landfill and the location. Now, there could be other connections too, to that spring.
Just because they're a spring doesn't mean that it's contaminated by the landfill, though.
Right.
Exactly.
But that's the steps you have to determine is where that that's the next step. If you do determine landfill derived chemistry. For example, you could look at PFAS, say PFAS is present at the landfill in the same types of PFAS are present in the landfill that they are in the spring, and therefore that contamination can't be coming from somewhere else. It's just, you can do forensics. Again, the idea is to protect human health and the environment.
I'm going to pass the witness, Chairman.
Thank you. Mr. Heister.
Thank you, Judge Moulton. Good afternoon, Mr. Hart. Are you ready to proceed?
I am.
Am I correct that you started your review of information for this site around November 2023?
I believe that's correct, yes.
And you're not offering any opinion today on whether the Class 1 expansion area design meets the technical requirements of Rule 22.425, are you?
No.
His name's come up several times, but I want to make sure we agree. Can we agree that Dr. John Brahana is a recognized expert in karst dye tracing?
I would say so, yes. Karst hydrogeology, dye tracing, yes.
And can we agree that Dr. Albert Ogden from Middle Tennessee State University is a recognized expert in karst and dye trace testing?
I don't know. I haven't looked at his work. I don't think he actually did the dye study in this case. I think he just reviewed it. So I don't know what he's done dye tracing.
The name will ring a bell to you, one way or the other. Fair.
I mean, I've seen it in these reports, but it doesn't, not like Dr. Brown.
All right. I just want to point out before we dive in, a moment ago, DEQ was asking you about the description of the conceptual hydrogeologic model and its permit. And I think you testified that was a summary of the model, correct?
Right. It doesn't even, I don't think, talk about types of rocks, so rock formations underneath. So it's a kind of a summary, but it's not a full conceptual hydrogeologic model under Rule 22, in my opinion.
Exactly. And so isn't it a little inconsistent that you refused to answer DEQ's question, but when you were shown the summary in section 6.0 of Eco-Vista's application, which was also a summary, you didn't point that out to the commission, the ALJ, did you?
What did I refuse to answer? Can you tell me what that is? What question did I refuse to answer? That you said I refused to answer a question. I'm trying to figure out what that was.
DEQ. Your critique of DEQ was the summary didn't contain enough information. And you were still willing to opine in front of this commission on the summary of Eco-Vista's hydrogeologic model. And that is in fact what you were talking about, section 6.0. You were aware that's just a summary, aren't you?
I don't know I'm sorry, I don't understand your question at all.
I guess I didn't understand your testimony. So
She asked me if what was in the permit was a conceptual hydrogeologic model, and I said, no, it is a summary of a model. I don't know, you claim that I didn't answer a question from ADEQ. I have no idea what you're talking about. Can you tell me what that was?
I certainly can. Judge, you're gonna have to bear with me a little bit because they changed the technology on us last minute. But that is a minor inconvenience to. I have to go back to paper, Your Honor. There's section 6.0 that was put in front of you. States the conceptual hydrogeologic model was last updated in 2023. Some studies. Findings from this investigation generally agree with the existing model, which is summarized. And that, in fact, was the language you were criticizing earlier as with respect to being an inadequate site hydrogeological
Well,
model.
the permit itself says it's a summary. The section is titled conceptual
I'm talking about
hydrogeological.
Yep,
You let me finish?
Wait a minute, everybody's talking at the same time and Gary's gonna be unhappy with me. So one at a time, please. You had a question pending. He was trying to answer it, Mr. Heister, and you interrupted him. So re-ask your question again, please.
So my question was, do you deny your testimony earlier today that the site hydrogeologic model was inadequate, was based on information in front of you at the time that was straight from 6.0? You deny that was a slide that you were looking at.
No, it says conceptual hydrogeologic model. This is, and I don't know what to say, I can't read that.
But
That to me doesn't say this, well, all
Yeah, well-
conceptual hydrogeologic models are, they're bulleted format. The top of that said, what was in the permit said it's a summary.
and
Of the
what you were
conditions.
criticizing earlier today is a summary.
Well, where is the conceptual hydrogeologic model then? Where is it?
I would expect you to know that before you opined on it, Mr. Hart.
Well, I haven't found it yet.
I think that's.
It should be, is it not in the documents? Where is it in the public
So
record?
let's talk about some of your specific Fortunately, we have other witnesses.
It
who
says
can answer this
conceptual.
question.
That's not, now, Mr. Hart, you interrupted him. One at a time.
It says
All right,
conceptual
so-
hydrogeologic model.
One of the, you place an awful lot of weight on the digest test studies. But in fact, a suite of information exists out about this site, including boring logs. True. I have a question.
What?
Boring logs exist that show the actual geology at various areas of the site. True.
Yes, there are some, but I mean, you have to take it all into account. I mean, borings are just like 2-inch diameter over a 600-acre area.
You do
Right,
have to
so you
take
have to
geology into
take-
account.
Yeah, right.
Please finish.
I would love to if you would let me. Yes, you have to take it all into account. You have to take the diatrace studies into account. You have to take the boring logs into account. You have to take the information that's been derived from people in the field that see voids and that kind of thing. All that needs to be incorporated.
Because the only, specific testimony you, testified today was all about the dye test and all about the voids and sinkholes you claim exist.
Well, the diatrace are very important. They can't be underestimated. They are actual indications of where groundwater is flowing, as opposed to just a potentiometric map, which in some cases, let me finish, please, but you're not. In some cases are not, especially in fracture geology, are not consistent with a potentiometric surface. You can get, in fact, if you read up on this, you can get contamination and groundwater flow that's not consistent with a potentiometric map. So the diatrasts are very important about groundwater, and that's what I'm here about, the hydrogeology.
Well, like I said, let's look at some of those dye tests. And wanted to start with the 1996 dye test that, again, I think you testified establishes a definite connection, strong connection was your testimony earlier today. So let's
With glass spring.
look at that. That's right, the glass spring. For the record, this is document ID 45474. So hydrogeological geotechnical report prepared in 1997 by Genesis Environmental Consulting. And unfortunately for us, the discussion we need is at the very end of it. And just to confirm, at the time of your deposition, when you formed the opinions we're discussing today, you had devoted a sum total of about 40 hours to studying these documents for the site?
Yeah, I think that's what I said, but I went back and looked, and I was wrong. It was closer to 60 hours. My apologies. I told you at the time, I did not know the exact number.
That is entirely fair. Right, so just let the record reflect that on the way there, we see the hydrogeologic model from 1997, and it goes on for pages. Okay, actually, I have one. Or appendix K with new information. Just to make sure or you agree with me that the well numbers, when it's SP is a spring, that was being sampled or monitored, correct?
You have to show me the report and what you're talking about.
So you don't know looking at this, or didn't you review this as part of your preparation?
I don't know what I'm looking at. I can hardly see it. Do you have a copy of it that I can look at?
And does that help?
There you go.
Yes, SP is a spring, without looking at the document itself, which you're not providing me. I believe that references a spring.
And you testified earlier about there being results in 1996 in SP6. You see those results here?
Yes,
And you see how they are in parts per billion?
yes.
And your testimony is these are clear indicators of a pathway of a positive dye test result. Is that
No,
your
I said
testimony?
there was a clear indicator at Glass Spring.
Okay.
And that was discounted at SP6 and the Great House Spring because they said that those were background.
Well, SP6 is to the northwest. So that's why I want to make sure the commission understands your testimony. Is your testimony that these 0.004, 0.015, that these results, which are in parts per billion, are evidence of a positive dye test result in SP6?
Potentially, yes.
Potential.
That's what I said. I said it showed a connection to Glass Spring and potential connections. That's why I had question marks at them at SP6 and Great House Spring.
So I take it you've reviewed this, the explanation in this report for the result in Glass Spring, true?
Yes,
And so, you're aware that the people conducting the study had concerns about how the results that you testified were clear at Glass Springs were, we can just read it. It shows an increase in fluorescence after injection, but the concentrations are low and nearly mimic those in other wells. It's not until 12/17/96 that Glass Spring shows a repeated increase over background. That's not considered a positive because it's reported by the owner to be influenced by Clear Creek. At times, Glass Springs is actually inundated by Clear Creek, and the fluorescent levels in upper Clear Creek samples are very similar to Glass Spring, strongly suggesting that the creek water is mixed with the spring's water.
is there a question?
I didn't hear anything in your testimony, correct me if I'm wrong, explaining or telling us why this explanation is inaccurate. I think you said they ignored it.
They did. I mean, the Glass Spring showed a repeated increase over background. But then they talk about I don't know who the owner is, right? The owner of what said it. They didn't observe it themselves.
Yes,
But
I'm sorry, I cut you off again.
well, my point is that they showed there's a clear connection if you look at the results to Glass Spring. They're saying it wasn't. I'm just saying I'm disagreeing with their interpretation.
So we have Dr. Ogden on one side, and we have Mr. Hart on the other, and the commission can decide which one's probably right.
Look, this is 1996. We're in 2024 right now, right?
We'll get there.
Are we denying that there's a connection to SP6 now? Just because Mr. Hart said so?
That's a little apples and oranges because these tests were conducted at different locations, weren't they?
Right.
Okay, well, I think we mentioned
In
it
my
during your
opinion, this was a connection to Glass Springs.
fair enough.
Right.
And
If Dr. Ogden wants to come here and testify about why he discounted it, that's fine. He can disagree with me. That's why we have different opinions about things.
I think unfortunately he's passed away.
Right.
However, I guess So the answer is no. I mean, you just don't like the fact that the creek that you're relying on gets inundated by a creek where there's a positive test, and the results just aren't reliable.
That's not true.
Okay.
In my opinion, they said that here's what I took from this. And I agree, there can be different interpretations. Glass Spring showed a positive indication. They said that the SP6 and Great House Spring were their upgradient points, but there is no upgradient here. They're all downgradient. So, and they said there were similar results. Well, to me, that would indicate that there's a potential connection to those two springs and to Glass Spring. That's what my interpretation is. That's my opinion.
Well, that may be your opinion now, but in your deposition, you said that they being EQ and Eco-Vista geologists also ignored the connections, the springs and areas of dye tracing, both to the south of Glass Springs and up Clear Creek. That's not true. They did not ignore it. They did conduct a follow-up analysis. Can you at least concede that?
They didn't do a follow-up to this
Okay.
dye trace. All they did was say, we don't think it's consistent with, that it could have mixed with something from Clear Creek. They didn't say it did. They said sometimes it does, but did that happen during the dye test? There's no indication that it did.
Okay.
And there's no hydrogeologist went out there and looked at this and say yes. They just said, we talked to an owner of the property, said it mixes with Clear Creek.
In all fairness, that's all that document I showed you said. You don't know sitting here today what additional work was done to support that conclusion, do you?
No, but that's what's in the record.
Well, no, that's what's in front of what I showed you.
No,
I
that's
want
what's
to
in the
move
record.
on to the.
Do you have something else that you want to show me from the record?
I don't know if you would have read it. I want to move on to the 2001 dye test. Because you're pretty critical of Dr. Ogden and Dr. Brahana's analysis of that one. In fact, I think even today, you testified your testimony is dismissive of the auto body shop explanation. Fair?
Fair.
And I think you testified there was no evidence whatsoever supporting that, and they should redo the test. Is that a fair enough summary of your thoughts on that?
Well, my thought is the reason they discount is because they didn't believe that there was solution conduit flow under this landfill, which is completely inconsistent with the geology, completely inconsistent with what you see in EPA guidance documents. And they tried to blame it on without any testing whatsoever, on some auto body shop that might have a release of antifreeze. And if there was a concern about it, wouldn't you, to me, you would redo the test. This shows significant issues, which is confirmed in 2022. Totally confirmed.
So we've talked about this before. This is a document ID 23178, the revised dye test study report. I think you talked about this a little bit with Mr. Noland earlier today.
And you indicated that Dr. Brahana was involved in this. I don't think he was involved in this study at all. I think it was just Dr. Ogden. We'll make sure that the record is clear.
Well, I will gladly accommodate you there. As you can see on what is page 2 of the report, there's a discussion about how Genesis Environmental Consulting and operations with Dr. Albert Ogden, helped prepare this work. He's an associate professor at the University of Arkansas, Fayetteville, for over 8 years. He's published extensively concerning groundwater flow characteristics in Northwest Arkansas. And this is Dr. Ogden, whose name is unfamiliar to you, except as it appears in these reports. And it concludes that the actual injection procedures were supervised by John Van Ronhana, PhD.
Right, so he supervised the injection, but he did not do anything with regard to the interpretation.
So we looked at this a little earlier today, and testified about, how you weren't persuaded the, 50 boring drillings and the, site geology they indicated were very persuasive to you. Neither was the groundwater information derived from 58 wells, seismometers, or gas probes. What I really want to ask you about was the third part, because that wasn't up on the screen very. And you'll see here, it says immediately upstream and 150 feet from SB6 is an auto repair shop. True?
That's what it says.
Okay, and on 2 separate occasions, die traps were placed approximately 50 yards upstream of the auto repair shop and 50 yards downstream of SP6. And the results can be found in Appendix C and are labeled Art Spring upstream and DWN SP6 downstream. As the results indicate, Art Spring result ranged from 0.471 to 1.253 parts per billion, whereas the result at SP6 and DWN SP6 range from 8 to 11 parts per billion, down gradient of auto repair shop. So apparently you weren't aware that they had gone back and placed samples above and below the auto shop and found a significant spike below the auto shop, were you?
No, I read this. Doesn't say that's what they did. That's not what they say they did.
That's not how.
They said we got an increase over background at the dye testing location. And it's very possible that there's springs located further up gradient. In fact, sampling now is done, I believe, at up to 3 springs in this area. So isn't it more likely, in my opinion, that whatever to the effect that there may be something upstream is associated with the injection rather than some phantom auto body shop that might have released antifreeze and might have gotten in the creek, is much more plausible that it's associated with the injection.
But just to be clear, when you testified earlier today, there was no evidence whatsoever. You were aware that dye traps have been placed upstream and downstream, and you just discounted that, correct?
Well, I think they discounted it too. I mean, they
No, they're citing this as a reason for why they couldn't find it.
I mean, to me, honestly, this is silly. This is silly, Bill, when you're talking about auto shops as a source of the exact same dye that was injected and shows up at a spring. And we know it shows up in 2024 and 2022.
It shows up in 2022 from a different location, Mr. Hart.
It's the entire landfill. It's all hydrogeologically connected. You can't parse out this landfill into little bits and pieces. That's not how hydrogeology works.
So just so the record is clear, are you testifying the hydrogeology under the site is uniform?
No, but it's interconnected. These caves are potentially interconnected. So one that shows up in one area can very well be interconnected to one in another area. It's a conceptual hydrogeologic model of the site. It's not a specific little area in the landfill every time.
This is document ID 32870. And we have another hydrogeologic and geotechnical investigation report. This was dated March 22nd, 2006. Here's the beginning of the hydrogeological and geotechnical investigation report. And it will say that it's revised March 2006. See at the bottom, page 61. You don't disagree that based on the 2001, 2002 dye test, DEQ requested that additional dye tests be conducted.
Yes, I think LF1 is my, the one that did it, LF1. Is
And in
my,
fact, they weren't just doing dye tests. The objective of the LF1 injection was to continue to repeat previous injection at this point that occurred during the 2001, 2002 test. And
right at LF1 that indicated a northerly flow. Check that.
that's what that, because we did some previous tests. The results of the 2001 test could not be confirmed. And just to kind of cut to the chase here. The dye injected into leachable LF1 was not detected above background, if you will, during the study. So, in fairness to DEQ and Eco-Vista, a follow-up was done to test whether to see if those results could be replicated, and they couldn't replicate them, could they?
They're talking about LF1. They're not talking about the spring sample.
Well,
They did sampling at LF1 that showed a northerly component. And so they tested LF1 again and didn't see any dietary. They didn't do it the spring sampling again.
SP6 was the sample point. LF1 was the injection point.
Right. But they didn't redo it. Look at that document again. Let me have that. See, you can't just give me something and pull stuff out of context.
I don't know.
Here's the deal.
Actually, in fact,
Here's what
No arguing again.
they
All right.
re-injected an LF1 to confirm, to determine whether, because there was a northerly flow component. They did not retest any springs. And if you have evidence to the contrary, show it to me.
I'm gonna keep this moving along. This is not the manner in which I hoped I wanted to be able to present some of this information for you. So here we have document 66023. Oh, it's not, there's a lag, sorry about that. Here we have. So see this, again, you don't dispute it's stamped by a professional geologist who reviewed the results, correct?
I don't even know what you're showing me, sir.
Oh, I'm sorry, I thought you saw it. Here you go.
Okay, thank you.
And this is from document 66023. You don't contest that it was signed and sealed by a professional geologist.
Okay. Agreed.
So here we see some results and summary of the 2012 and 2013 dietaries. And I think we already discussed, we all know, Dr. Bahana was involved with that among others. In fact, for example, starting at 27 here, Dr. Rahal has a discussion about some of the problems that this particular site faces, partially a result of how much dye testing has been conducted.
I can't read that. I'm not sure where you're reading from. I'm sorry.
Oh, there you go.
But thank you. Okay, what, is there a question?
No, I'm just trying to orient you. I mean, you don't disagree, for example, with Dr. Bahana's, observation that, fluorescein, a dye, for example, wasn't used during the current dye tracing study, but they were still, some of the results were showing result for that he addresses. You don't take any issue with this analysis, do you?
No, I mean, they didn't inject fluorescein. He was just noting that they were still detecting it because it was an area that probably had low groundwater flow.
Yeah, no, yeah, that's right. That's
An isolated area that had low groundwater flow, but it really wasn't related to the injection of the dye that was done for this investigation.
And you don't dispute Dr. Bahana's observation that it's been documented that dyes persist underground for many months or years, correct? Or that flushing from the regolith of the Eco-Vista landfill has not been rapid or complete in some areas?
Yeah, I don't have, I mean, it seems, I didn't have any objection to that. No.
Then he has a discussion of questionable positive detections noted in the report. He says, these are not discussed in detail in his report, except for SP6 and Up Clear Spring, in 2 offsite springs that do not qualify for being a positive trace. But that for hydrogeologic reasons or previous dye traces have yielded anomalous data that justifies examining. Did I read that correctly?
Right, and if you go on, they further discuss in this document about the detection of Clear Springs, that it was a most likely resurgence from fast flow conduits from the injection. Do you want to read on in this document? We can go to that part if you like.
Do have. Like, for example, here, Dr. Bahana points out the EVLF, Eco-Vista landfill site, does not display classic sinkhole-dominated bedrock karst having obvious surface landforms. The bedrock is covered, mantled, with a relatively thick layer of insoluble clay and chert, and groundwater fat is concentrated in zones of intensive weathering in the epikarst transitional zone, including regional on top of indurated rock, which represents a major permeability contrast for this aquifer. So again, I guess on one side of the argument, we have Mr. Hart saying this is a typical karst site. And on the other, we have Dr. Bahana saying this site does not display the classic sinkhole-dominated bedrock karst having obvious surface landforms. So was this for the ALJ to decide who's more likely to be right?
Well, there's certainly some. You can see them, and they actually found some previously. You can see them in the topographic maps.
Well, apparently you see them, Mr. Hart, but I'm not sure Dr. Bahana did. But we'll get to
He doesn't say there's not any. He just says it's not a classic.
Well,
it's dominated.
Maybe it's more fair to say you haven't read anything where he didn't say the one thing. Is that a more accurate statement?
I didn't understand your question.
Sure. Is it more accurate statement from you that you haven't read anything where Dr. Brahana says there are none of those features on the site?
I don't know that, I mean, I haven't seen anything that Dr. Brahana said that he did an evaluation for karst landforms at this site. His involvement has been supervising studies and and some of the interpretation in the later study.
So here we have a summary of November 2005 to January 2006 dye tracing test prepared by Dr. J.D. Brahana and Dan McCulloch. I think we're still in document 32870. And what follows is a discussion. See what Dr. Brahana says on that issue. Says a karst inventory reveals no surface streams are present on the WMGL site, nor caves, sinkholes, swallets, Uvalas, springs, or surface springs or related optimum karst dye tracing sites known to occur on the WMGL site. So
In
again,
2019, FTN found 16 of them. So who's wrong?
we'll get into that. But my question for you is, you don't dispute that Dr. Brahana did perform a karst inventory of at least some part of the waste management site. Standing here, do you have any information to say he didn't do this?
No, that's what he says. Like I said, I see evidence, and I don't know the extent of the landfill at the time necessarily. I see evidence in historical topographic maps of sinkholes. I see evidence in the documents that show voids.
Sure.
Right?
Yeah,
He may not have had that information.
that's true.
I see information that shows that there is conduit flow from this site to SP6. Even if you don't believe any other dye test studies, if you believe the one from 2022, that clearly is evidence of fast conduit cave stream flow. Now, he also doesn't say there are none. He just says there are none that are optimum dye tracing sites.
Well, let's see what Dr. Brahana had available to him in 2005 to help him or prevent him from missing the sinkholes that you discovered. You reviewed Geosyntex 2002 report here, document ID 18105, didn't you?
Yes.
Okay. And you see this report that's stamped by a professional engineer, true?
I can't, you scrolled somewhere where I can't see. Oh, there it is. I'm sorry. Yes,
And you are not an Arkansas registered professional engineer, true?
I'm not.
let's look at some of the professional engineers' findings in 2002. He states a review was conducted that involved discussions with waste WDMTL and construction contractor personnel. And it appears no more than 5 voids were encountered during excavation for the permitted landfill. Do you see that?
It says in the regolith,
Yes.
doesn't say the entire section. It says the regolith, which is the clay material at the top.
You think
Not
they,
that-
you
not
think,
that you would-
are you testifying, you think they omitted material information, this report?
I'm just saying that's what it says.
Okay.
It doesn't say anything about the epicars, which is where you'd expect to find more voids. It says the regolith.
And do you know what part of the property is excavated for purposes of building the class 1 area that sits there today?
I don't understand your question.
I mean, you do understand that that they were excavating, the northern area of the landfill for a class 1 expansion that led to the discovery of the voids in the, what are the 12x2 cave-in that you mentioned earlier?
Right.
You did understand that, right?
Yeah.
Okay, and did you understand that BEQ required a follow-up geotechnical investigation to see whether there was any issues of concern there with stability of the underlying rock?
I don't know.
Okay, well, maybe you didn't review this report as closely as you thought.
My
You'll
point
see
is what
here,
that says is the regolith,
there's
not
there's,
the entire I mean,
I mean, I'm gonna make sure this is clear. I mean, is your testimony that this report didn't look at a relevant part of the geology when they're investigating the class 1 area?
well, then it goes on to say another void was encountered in weathered rock at the regolith bedrock contact.
And
I'm just reading what's in the report. I'm not asserting anything. But when you asked me, was there any voids found? What my point was, it was that sentence only said the regolith.
and my question was, did you know whether they would be digging another area for purposes of the excavation? And I don't know if I got an answer to that.
I don't think you asked that question.
Okay. I'm not sure. We can talk to an engineer about that. Let's go to the very last 2 sentences where Geosyntech reiterates that only 4 small voids and 1 additional slightly larger void related to the regolith/bedrock contact zone were encountered in the nearly 360,000 cubic yards of regolith excavation in the North Figs. Thus, the occurrence of such features at the site is uncommon.
Well, they say again, the regolith. They don't talk about the underlying epicars, which is where you're more likely to find voids.
And is it your testimony that the engineers didn't think about that when preparing the calculations for whether the bottom of the
Read
landfill?
what that said.
I-
It says the regolith.
That's
It
right.
doesn't say anything about the epicars.
So you don't know, at what general level, elevation does the epicars occur under the class 1 area being discussed here?
Well, it depends on where you are. Oh, the class 1 expansion area,
Mhm.
probably around 20. Well, it depends, 20 feet
And
ish.
20
It
feet.
goes
What's-
20 to 30 feet.
What's the surface elevation, to sea level
About before the landfill, now,
before?
I don't know. off the top of my-
And what level is the groundwater under this area?
I don't know. off the top of my-
Wouldn't you need to know those details, Mr. Hart, in order to have any opinion on whether the void could be remotely close to the bottom of the liner of the class 1 area being built?
They said right in the report that 12-foot by 2 to 3 foot wide one was near the base of where they were going to put the line.
In the excavation area?
But
And they concluded that the occurrence of voids was actually uncommon at the site, didn't they?
in the regolith, yes.
You testified earlier about a collapse that occurred that you saw discussed in an affidavit in the record, correct?
Yes.
Did you look anywhere else in the record to see what sort of follow-up or investigation of that collapse might have been conducted?
I attempted to, I mean, there's thousands of documents, but I looked around that time frame, but I didn't see it.
But you felt like you understood it well enough to come here and testify today that subsidence occurred in 2001, didn't you?
Well, yes, it says that a collapse occurred.
And if you had looked further into the record, you would have seen that an investigation showed that a local retailer sent a bunch of off-spec scarecrows to the site that compressed. Did you see that in the record?
Do you have, I don't know what you're talking about. Do you have something to show me?
I asked you, did you see it in
I think you're implying that it's in the record, but if you have something to show me that's from the record, I'd be glad to look at it to know what you're talking about. I don't know what you're talking about.
That's what I wanted to establish, Mr. Hardin.
Scarecrows? What is it?
I'm sorry. I'll tell you what, Mr. Heister, I don't want to break off your cross. I don't know how much more time you have. How much more time do you have?
15 minutes?
Mr. Hart, are you going to be around again tomorrow?
Yes,
Okay. I'll tell you what,
as of right now.
as of right now, yeah. Well, I have questions as well. Mr. Nolan may have some redirect. I don't think, and I know Mr. Asher still has another 15 or 20 minutes left, maybe longer than that. It is 5:15. I think it's a good time to take a break. Okay. Mr. Nolan? Yeah. All right, we're gonna go ahead and go off the record. I guess 9 o'clock as well. We still have a number of witnesses I think we need to get through. So we'll come back on the record tomorrow morning at 9. Mr. Nolan, just before we actually go off the record, is Mr. Hart your last witness or do you have other witnesses?
I think it is, I would confirm. Again, with the public counsel, do they intend to call on their record? I
Understood.
believe that will, in fact, again, confirm that we will close.
Assuming they're gonna call who you wanna question.
I think I can take care of what I need to do on cross, so I will ask that question again in just a moment, and then I expect to be able to close after,
All right.
Mr. Hart's.
Okay, you don't have to stand, it's fine. All right, we're off the record. We'll see you tomorrow morning.